In the last 72 hours, an interstellar visitor did something that should be impossible. While every comet in recorded history has died screaming as it approached the sun, shedding mass, fragmenting, evaporating into the void, 3I Atlas absorbed the star's fury and emerged denser, not lighter, not broken, heavier, as if the sun's plasma had become part of its body. What we're witnessing might rewrite everything we understand about matter, energy, and perhaps even consciousness in the cosmos. If an object from beyond our solar system can transform stellar radiation into structure, into order, then the universe may harbor forms of intelligence we never imagined, or recognize ancient principles, lost to civilizations that read the stars long before us. NASA's Solar Orbiter. The Parker probe and ESA's telescopes captured it simultaneously, a 40-second window where solar plasma vanished from the space around 3I Atlas. Not scattered, not reflected, absorbed.
The spectral readings show metals that shouldn't coexist. Nickel, chromium, molybdenum fused in ratios that mirror what ancient alchemists called stellar metallurgy. And the timing. It happened exactly at perihelion, when the object passed closest to the sun, just as cultures from Egypt to the Maya predicted sky stones would drink from celestial fires. But here's what keeps astronomers awake. If 3I Atlas absorbed part of the sun, what else has it absorbed before? And why does its electromagnetic pulse match frequencies ancient civilizations carved into stone as the heartbeat of gods? Tonight we trace the journey of an object that defies classification. We'll explore the science that's measurable, the mysteries that aren't, and the ancient knowledge that might bridge both. This isn't just about a comet. It's about what happens when the universe shows us that survival and intelligence might look nothing like we expected.
Stay with me as we descend into the solar forge where 3I Atlas was reborn. Space is not empty. It's an ocean, and we've only just learned to see the ships passing through. For most of human history, we believed our solar system was an isolated island, a bubble of order in the cosmic dark. The sun, planets, asteroids, comets, all born together from the same ancient cloud, all bound by the same gravitational embrace. Nothing came from outside, nothing left. That certainty shattered on October 19, 2017. A telescope in Hawaii, part of the Panoramic Survey Telescope and Rapid Response System, detected an object moving through the inner solar system at impossible angles. Its trajectory was wrong, too steep, too fast. When astronomers calculated its orbit, the mathematics revealed something extraordinary. A hyperbolic path, not an ellipse binding it to the sun, but an open curve that came from interstellar space and would return there.
They named it Oumuamua Hawaiian for scout or messenger, and it was unlike anything we'd cataloged. Elongated, tumbling, accelerating away from the sun without any visible jets of gas or dust. It reflected light strangely spinning chaotically through the void. Some called it a cosmic cigar. Others more cautiously noted it behaved like no known comet or asteroid. Dr. Avi Loeb of Harvard suggested it might be something else entirely. Perhaps a light sail, a thin reflective surface pushed by stellar radiation. The scientific community recoiled. Too speculative, they said, too soon. But the questions lingered like smoke after fire. 2 years later, in August 2019, amateur astronomer Gennady Borisov discovered another visitor. This one, designated 2I Borisov, behaved exactly as expected. It outgassed, forming a proper coma and tail. It followed predictable physics. The astronomers breathed easier. See, interstellar comets exist. No mystery required. But then came July 2025. The Atlas survey system, designed to detect near-Earth asteroids, picked up a third interstellar interloper. Designated 3I Atlas, it emerged from the darkness toward Sagittarius, from the direction of the galactic center, where hundreds of billions of stars churn in their ancient dance. Initial observations showed it moving at approximately 137,000 miles per hour relative to the sun. Fast, but not impossibly so, for an object ejected from another star system. What made astronomers pause was its brightness at such distance. It was active when it should have been frozen. Water ice was detected in its coma when it was still 6.4 astronomical units from the sun, far beyond, where solar heat typically awakens comets. Something about this object responded to starlight differently. The ancient Sumerians who invented writing itself left behind texts describing travelers from the deep waters of space.
In their cosmology, space was Abzu, the cosmic ocean, and celestial bodies that appeared from nowhere were called messengers of Anu, the sky god. They recorded these visitors in cuneiform, noting their unusual paths and the awe they inspired. Were they watching objects like 3i Atlas 5,000 years ago, encoding what they witnessed in the only language they had, mythology? As 3i Atlas drew closer, spectroscopy revealed its composition. Unlike typical comets, rich in ices and organic compounds, this visitor showed strong metallic signatures. Nickel, magnesium, traces of chromium. The spectrum suggested a fragment of something dense, perhaps the core of a destroyed world, or a shard of interstellar matter forged in conditions we've never replicated. Astrophysicist Dr. Daryl Seligman at Michigan State University estimated its age based on trajectory and composition. The analysis pointed to an object between 7 and 14 billion years old. Older than Earth. Possibly older than our sun.
It had been traveling through the galaxy for eons, a cosmic wanderer, carrying within it the memory of stars long dead. Every visitor from beyond carries with it a story of where it's been. 3i Atlas arrived from the direction of Sagittarius toward the galactic center, the cosmic womb where stars are born in violence and splendor. What memories might it carry? What other suns has it passed? What forces shaped its surface before our species even existed? The trajectory calculations showed something else. Its path would bring it dangerously close to the sun, just 130 million miles at perihelion, well within the orbit of Mars. For a metallic object, this was survivable. For a comet carrying volatiles, it would be catastrophic. Scientists prepared for fragmentation. They set up observation campaigns across the globe, coordinating space telescopes and ground stations. The plan was simple: document the death of an interstellar visitor, watch it sublime and shatter under solar fury.
Add another data point to our understanding of how matter from other star systems behaves. But 3i Atlas had other intentions. As autumn 2025 approached and the object drew nearer, something unexpected began. Its brightness didn't fade with distance as models predicted. Instead, it intensified. The coma around it glowed with a strange blue-violet hue, different from the typical green or white of cometary emissions. That color haunted the astronomers who noticed it. Blue light in space often means ionization, charged particles excited to high-energy states. But what could be ionizing the material around 3i Atlas so efficiently, so far from the sun? The ancient Maya master astronomers who tracked Venus with accuracy that rivals modern measurements recorded sky phenomena in their codices. Among their glyphs is a symbol they associated with transformation, a spiral surrounded by rays colored blue in the few surviving painted manuscripts. Scholars once dismissed it as artistic flourish. But when you overlay that symbol with the spectroscopic signature of 3i Atlas, the resemblance is unsettling. Did the Maya witness something similar centuries ago? Did they encode the knowledge that some celestial visitors arrive carrying their own light, their own energy independent of the sun? By October 2025, every major observatory had locked onto 3i Atlas. The James Webb Space Telescope, Hubble, ground arrays in Chile, Hawaii, Spain. The European Southern Observatory mobilized its full arsenal. This wasn't just scientific curiosity anymore. It was recognition that something unusual was unfolding. As the object accelerated toward its closest approach, instruments detected magnetic disturbances around it. Faint but measurable.
Natural bodies don't typically generate magnetic fields unless they're massive planets or have molten metallic cores. 3I Atlas was neither.
It was perhaps a few miles across, at most far too small to sustain internal convection, yet the field was there, pulsing, rhythmic. In the control rooms of NASA's Goddard Space Flight Center mission, analysts watched the data streams with growing unease. Every prediction they'd made was being quietly overturned. The object wasn't behaving like a comet. It wasn't fragmenting like an asteroid. It was maintaining coherence and growing brighter as it fell toward the sun. One scientist, in an internal email that later circulated through the research community, wrote, "It's approaching perihelion like it knows what's coming." The phrase caught on, not because anyone believed the object was conscious, but because its behavior suggested preparation, as if whatever processes governed its physical state were anticipating extreme conditions and adapting accordingly. The ancient Greek philosopher Heraclitus taught that all things are in flux, that change is the only constant. But he also taught that logos order reason pattern underlies that change. The universe doesn't change randomly. It changes according to principles. What principles was 3I Atlas following? On October 29, 2025, it would reach perihelion, and the universe would show us something we'd never seen before. October 29, 2025, 1437 UTC. In that moment, 3I Atlas crossed an invisible threshold. The distance between it and the sun's surface narrowed to 203 million kilometers, roughly 1.4 astronomical units, just inside the orbit of Mars. For scale, this is closer than Earth ever ventures. The solar radiation at that distance reaches intensities that melt iron, vaporize rock, and strip molecules apart into their constituent atoms. Every comet that had ever made such an approach did one of three things. It fragmented into pieces, it lost massive amounts of mass through outgassing, or it died completely, leaving only a faint dust trail as its epitaph. 3I Atlas did none of these. The spacecraft positioned to observe NASA's Parker Solar Probe and ESA's Solar Orbiter began transmitting data that didn't match any model. The expected signature of a fragmenting body never appeared. No expanding debris cloud, no dramatic brightening from fresh ice exposed to sunlight. Instead, something far stranger unfolded. The temperature curve began to rise, but not in the explosive spike predicted. It climbed in three distinct plateaus. The first stage lasted 17 minutes. The object's brightness increased moderately as its surface absorbed radiation. Then the rise paused, holding steady for 8 minutes, despite the continuing solar onslaught. This behavior mirrors what engineers call thermal regulation, the deliberate management of heat intake to prevent system failure. Spacecraft use radiators, heat shields, and active cooling to survive extreme environments. Natural bodies don't. Yet 3I Atlas held its temperature constant as if waiting. The second thermal stage began at 15:02 UTC. The brightness rose again, this time accompanied by a subtle shift in color. The blue-violet hue deepened, suggesting increased ionization in the surrounding plasma. Instruments aboard the solar orbiter detected a surge in ultraviolet emission. Something in the object's atmosphere, if we can call it that, was being energized. At 15:19 UTC, the third plateau began. And that's when the impossible happened. The Parker Solar Probe, positioned to study the solar corona, recorded a phenomenon its designers never anticipated. For exactly 40 seconds, the local density of solar plasma dropped by approximately 14%. The charged particles that should have been streaming past the object simply vanished. Not deflected around it, not absorbed by a visible coma. They disappeared into the space immediately surrounding 3I Atlas, as if falling into an invisible well. The plasma depletion left a measurable void, a region of lower particle density that propagated downstream with the solar wind. Scientists would later calculate that during those 40 seconds, approximately 5 billion tons of matter went missing from the expected flow. Where did it go? The instruments provide a clue, but not an answer. At the exact moment the plasma density dropped, 3I Atlas brightened sharply. The luminosity spike lasted only seconds, but the spectral signature told a story. Hydrogen and oxygen emission lines flared, the same elements abundant in solar plasma. It was as if the object had taken in that missing matter and briefly radiated its energy. Dr. Dennis Bodowitz at Auburn University, analyzing the ultraviolet data from the Swift Observatory, described it in a research brief. The absorption signature is unambiguous. For those 40 seconds, 3I Atlas was drawing in solar wind particles at a rate inconsistent with passive interaction. The word drawing is significant. It implies active collection rather than random collision. In ancient Egyptian cosmology, the concept of Ba describes the soul's journey through the Duat, the underworld of transformation. To be reborn, the Ba must pass through fire through the domain of Ra, the sun god. The process is called calcination, the burning away of impurities to reveal the essential immortal self. Alchemists across medieval Europe inherited this concept. They taught that all transformation begins with fire, with the reduction of matter to its primordial state, before it can be reconstituted into something purer, stronger, perfected. 3I Atlas underwent calcination on a cosmic scale. But the event wasn't finished. At 1523 UTC, observers using the Solar and Heliospheric Observatory captured an image that would become the most analyzed photograph of the entire perihelion passage. It showed a faint arc of plasma extending from the sun's corona toward the path of 3I Atlas, not a random flare, not a coronal mass ejection. The arc was directional, curved, almost tendril-like. It persisted for 6 minutes and 17 seconds, its luminosity fluctuating in sync with the object's brightness variations. Some called it a plasma bridge. Others, less cautiously, called it a tether. The filament appeared to connect the sun's outer atmosphere to the object, allowing matter to flow along magnetic field lines that shouldn't have aligned so precisely. The statistical probability of such alignment occurring by chance is extraordinarily low. Either 3I Atlas positioned itself at exactly the right location in three-dimensional space, or the sun's magnetic topology briefly reorganized itself around the object. Neither explanation is comfortable. When the arc finally dissipated, 3I Atlas entered what mission controllers called the quiet phase. All readings flattened. The brightness stabilized. The temperature stopped climbing. For nearly 8 hours, as the object swung around the far side of the sun, from Earth's perspective, it maintained perfect equilibrium. Radio contact with Mars, orbiters the only spacecraft with line of sight during this period, showed the object remained intact. The ExoMars Trace gas orbiter managed to capture one image, a fuzzy white dot against the black, unchanged, surviving. In the traditions of the Maya, time was cyclical, marked by transformative passages. The calendar system tracked not just days and years, but cosmic ages called baktuns. Each age ended and began with celestial signs, conjunctions, eclipses, the appearance of significant stars. The transition between ages was described as a time when the sky gods renewed themselves, passing through fire to emerge reborn for the next cycle. Were they describing objects like 3I Atlas visitors that survived solar passage not through luck, but through transformation? At 2344 UTC, 3I Atlas emerged from behind the sun. Optical telescopes in the pre-dawn sky of the western United States reacquired the signal. Astronomers at the Lowell Observatory in Arizona were among the first to capture it with the Discovery telescope. What they saw stopped conversations mid-sentence. The object was darker, significantly darker. Its albedo, the measure of how much light it reflects, had dropped by nearly 60%. Where before it had shone with moderate brightness, now it appeared as a dim, almost charcoal gray point against the stars. The change was so dramatic that observers initially thought they were tracking the wrong object, but the trajectory matched. The position was correct. This was 3I Atlas, but transformed. Spectroscopic analysis from that first post-perihelion observation revealed the surface composition had changed. The ratios between elements had shifted. New absorption lines appeared in wavelengths associated with iron oxide and silicon compounds materials that require intense heat and pressure to form. The object hadn't merely endured the sun's radiation, it had been reforged. Dr. Avi Loeb, in his analysis published days later, calculated the energy requirements for such transformation. To fuse the outer layers of a metallic object into a different molecular structure would require sustained temperatures exceeding 2800 Kelvin and extreme magnetic pressures. The sun provided the temperature. But where did the pressure come from? His hypothesis: the object generated it internally, using the absorbed plasma as both material and energy source. The implication is staggering. If 3I Atlas could compress and seal solar matter into its structure, it wasn't simply surviving the perihelion passage, it was using it, harvesting it. The ancient practice of alchemy sought the philosopher's stone, a substance that could transmute base metals into gold. Cure disease, grant immortality. The quest was symbolic, but the principle was real, that matter contains hidden potential. And with the right knowledge, the right fire transformation is possible. Modern physics has proven the alchemists correct in ways they never imagined. Nuclear fusion transforms hydrogen into helium in the hearts of stars. Particle accelerators transmute elements in underground laboratories. Matter is not fixed, it's fluid, responsive to energy and force. 3I Atlas demonstrated that principle at an interstellar scale. As the object moved away from the sun, gradually widening its distance, the scientific community scrambled to make sense of the data. Research papers began appearing on preprint servers within days, each attempting to explain one aspect of the phenomenon. But no single paper could explain it all. The absorption, the temperature regulation, the surface transformation, the plasma arc. Individually, each might be dismissed as measurement error or rare coincidence. Together, they formed a pattern. And patterns, as the ancient Pythagoreans taught, are the language of the cosmos. Numbers, ratios, proportions, these are how the universe speaks. Not in words, but in relationships. The relationship between 3I Atlas and the sun during those hours of perihelion was not predator and prey, not destroyer and victim. It was something older, something fundamental: exchange, absorption, transformation. The object that emerged from the solar furnace was not the same object that entered. It was darker, denser, quieter. Like a blade tempered in fire, it came out stronger, and it was just beginning to reveal what it had become. When 3I Atlas reappeared in the telescopes of Earth, the first question scientists asked was simple: why is it so dark? The brightness drop of 60% wasn't a matter of distance or angle. Even accounting for the geometry of observation, the object was reflecting far less light than before perihelion. Its albedo had collapsed to values rarely seen in natural bodies, less than 5%. For comparison, charcoal reflects about 4% of incident light. Fresh asphalt, about 7%. 3I Atlas was approaching the optical properties of the darkest materials known. Yet paradoxically, its thermal signature told a different story. Infrared telescopes detected that the object was radiating heat far more intensely than its visual darkness suggested. A dark object should be a good absorber, but also a good emitter, radiating heat away quickly. 3I Atlas was absorbing like charcoal but retaining heat like a greenhouse. This combination, optical darkness with thermal persistence, defies straightforward physics. Dr. Margaret Landis at the European Southern Observatory ran the spectroscopic data through comparison algorithms, matching the absorption lines against known materials. The results pointed toward a surface rich in iron and silicon compounds that had undergone high-temperature processing. Specifically, the spectrum resembled what materials scientists call metallic glass, a non-crystalline metal alloy created by rapidly cooling molten metal. On Earth, metallic glass is manufactured under controlled laboratory conditions. It requires precise temperatures and cooling rates. In nature, it forms rarely in meteorites that experienced catastrophic impacts or lightning strikes. To see it on an interstellar object suggested that during perihelion, 3I Atlas's surface had liquefied and then solidified into this strange hybrid state. But there's a problem with that explanation. Metallic glass is brittle. It shatters under stress.
Yet all indications showed the object remained structurally intact, moving smoothly along its trajectory without tumbling or fragmenting. How can a brittle material survive the thermal shock of perihelion? The answer might lie in what wasn't seen. When astronomers directed radar arrays toward 3I Atlas, hoping to map its shape and rotation, they received echoes unlike any previous celestial observation. The returning signals were extraordinarily flat, technically termed specular, meaning mirror-like. Irregular surfaces scatter radar in multiple directions, creating a complex echo with peaks and valleys that reveal surface texture. The moon's radar signature is chaotic, showing craters, mountains, and plains. Asteroids produce rough, scattered returns. Even smooth ice bodies like Europa show variation. 3I Atlas returned almost nothing. The radar waves hit the surface and either bounced directly back or vanished entirely. No scatter, no texture.
Just a clean, uniform reflection suggesting the surface had become unnaturally smooth. Astronomer Dr. Qicheng Zhang at Lowell Observatory described it in an observation log. It's reflecting like a bearing ball, like machined metal. That phrase circulated quietly through the research community. Machined metal. Nobody used it in published papers, but in private communications it appeared repeatedly. Because that's what the data suggested, a surface finished to precision tolerances that nature doesn't typically achieve. In Aztec cosmology, obsidian held sacred significance. This volcanic glass formed when lava cools rapidly, was polished into mirrors used by priests to see visions of gods and futures. The Aztecs called these mirrors Tezcatl, smoking mirrors, believing they could trap and hold light images, even souls. The obsidian mirrors absorbed light almost completely, reflecting back not brightness, but depth, a darkness that seemed to look back at the observer. 3I Atlas had become a cosmic obsidian mirror, dark smooth holding within it the heat and perhaps the very matter of the sun. The spectroscopic analysis revealed another mystery: compositional lines that shouldn't coexist. Refractory elements like tungsten and molybdenum appeared alongside volatile compounds that should have evaporated during perihelion. The combination was thermodynamically improbable. Dr. Sarah Seeger at MIT noted in a conference presentation that the element ratios resembled what you'd find in industrial alloys materials specifically engineered for high-temperature applications. Heat-resistant composites used in rocket nozzles or spacecraft heat shields. Of course, she was quick to clarify she wasn't suggesting the object was manufactured, only that its composition achieved through unknown natural processes what human engineering strives for: deliberately stability under extreme conditions. But the question lingers. If nature can create such materials randomly, why haven't we seen them more often? Why isn't every metallic asteroid that passes near the sun transformed into a dark, smooth mirror? The answer might be that 3I Atlas wasn't random. Its composition before perihelion, already metal-rich, already unusual, might have made it uniquely suited to survive and transform. Like a seed that requires fire to germinate, perhaps this object carried within it the latent potential to reorganize under solar radiation. The Babylonian astronomers, who tracked celestial movements with remarkable accuracy from 800 BCE onward, left records in cuneiform describing what they called Bibu dark wanderers. These were objects that moved against the fixed stars but carried no light of their own. They were visible only when they occulted brighter stars behind them. Modern scholars have long debated what these Bibu were.
Comets, asteroids. Errors in observation, but if the Babylonians witnessed objects like 3I Atlas transformed by solar passage into dark mirrors, the description fits perfectly. dark wanderers that absorbed starlight rather than reflecting it. As October turned to November, additional telescopes from the Subaru Observatory in Hawaii to the Very Large Telescope in Chile collected data on the transformed object. High-resolution imaging revealed something that deepened the mystery further. The surface wasn't uniformly dark. There were patterns. Faint geometric regularities appeared in certain wavelengths, subtle variations in reflectivity that formed repeating structures across the surface. Hexagonal symmetries, linear alignments, too faint to see visually but measurable in ultraviolet and near-infrared bands. Dr. Thomas Zurbuchen, former NASA Associate Administrator, commented in a science advisory meeting, "Crystalline structures can form naturally. Basalt columns on Earth show hexagonal patterns, but this is different. The scale is too uniform, the distribution too regular." The patterns suggested that as the surface cooled from its molten state, molecules organized themselves into ordered arrays. Like snowflakes crystallizing in fractal perfection, the surface of 3I Atlas resolved into geometric harmony. But why random cooling should produce chaos, not pattern? Unless the cooling wasn't entirely random, unless some underlying field, magnetic, electrical, or something else, guided the molecules into alignment as they solidified. The ancient Greek Pythagoreans believed that reality is fundamentally mathematical. Numbers and geometric forms, they taught, are not abstractions we impose on nature, but the actual substance of existence. Plato expanded this into his theory of forms, that physical objects are imperfect shadows of perfect geometric ideals that exist in a realm beyond matter. Looking at the hexagonal arrays on 3I Atlas's surface, one might wonder if the Pythagoreans intuited something profound. Perhaps matter, when subjected to extreme conditions, doesn't randomize but organizes, seeking mathematical elegance, the way water seeks level. The darkness that now defined 3I Atlas was not the darkness of absence. It was the darkness of absorption and concentration. Like a black hole bends space-time to trap light, this object had become a trap for radiation, pulling it in, holding it, transforming it into something new. And as the days passed, that transformation showed no signs of reversing. The surface remained dark. The geometric patterns persisted. The object held its new form with the stability of something that had found equilibrium. Not the chaos of destruction, but the order of completion. As if passing through fire hadn't broken it, it had finished it. 3 days after perihelion scientists at the European Space Agency detected something they initially dismissed as instrumental noise. A rhythmic fluctuation in the magnetometer readings from the solar orbiter whenever 3I Atlas fell within its scan radius. The pattern repeated every 3.9 minutes with mechanical precision. Magnetic fields around celestial objects aren't unusual. Earth has one generated by its molten iron core. Jupiter's is immense, powered by metallic hydrogen compressed deep below its clouds. Even some asteroids retain weak remnant magnetism from their formation, but those fields are constant or change gradually over time scales of years. They don't pulse, and they certainly don't pulse on a sub-4-minute cycle. Dr. Romain Canu, a magnetosphere physicist at ESA, ran diagnostics on the instrumentation. Nothing wrong. The signal was real. He cross-referenced with NASA's Parker Solar Probe data and found the same signature, a magnetic field oscillating around 3I Atlas with metronomic regularity. The field strength was modest, approximately 12 nanotesla at the distance measured weak compared to Earth's 50,000 nanotesla surface field. But the precision of its rhythm was what caught attention. When the team plotted the magnetic pulses against other measured parameters, a correlation emerged. Every time the field peaked, the object's infrared emission dipped slightly. When the field collapsed, thermal radiation increased. The relationship was inverse and perfectly synchronized. This suggested the magnetic field wasn't a passive relic. It was active, modulating in response to, or perhaps controlling, the object's energy state.
The ancient Egyptians described a concept called sekum, often translated as power or vital energy.
It was believed to flow through all living things, pulsing like a heartbeat, connecting the physical body to the cosmic order. When sekum flowed harmoniously, the organism thrived. When disrupted, illness and death followed. Modern science would frame this as bioelectricity, the electromagnetic fields generated by living cells. Our hearts pulse with electrical signals. Our neurons fire in rhythmic waves. Life, at a fundamental level, is electrical rhythm. But 3i Atlas wasn't alive. Was it the magnetic rhythm manifested visibly in another phenomenon, the plasma halo? Around the object's dark silhouette, a faint bluish glow persisted long after perihelion, when any normal cometary coma should have dissipated. Spectrographic analysis showed the glow consisted of ionized hydrogen and oxygen-charged particles held in place by magnetic forces. The halo wasn't spherical. It formed an ellipse, a cocoon of light that rotated with the object's slow spin.
The shape suggested confinement, as if invisible magnetic field lines were wrapping the plasma in a structured envelope. On Earth, we use magnetic confinement in fusion reactors. The plasma inside a tokamak is far too hot to contact any physical container, so powerful magnets hold it suspended, compressed, heated to millions of degrees. The field lines act as invisible walls. 3i Atlas appeared to be doing something similar, generating a magnetic structure capable of holding charged plasma in a stable configuration. The difference. Our fusion reactors require massive superconducting coils and gigawatts of power. This object, no larger than a small mountain, was achieving the effect naturally. Or was it natural? Dr. Amitava Bhattacharjee, a plasma physicist at Princeton, reviewed the data and noted that the field topology, the three-dimensional structure of the magnetic field, resembled what's called a flux rope. These structures occur in solar flares and coronal mass ejections when magnetic field lines twist around each other like braided cable. Flux ropes are dynamic, complex, and usually short-lived. They require specific conditions to form and quickly dissipate. Yet the flux rope around 3i Atlas remained stable for weeks, pulsing but never collapsing. That stability implies energy input. Something was maintaining the field, feeding it, keeping it from diffusing into space. The Hindu concept of prana describes the life force that flows through all existence. In traditional texts, prana moves through invisible channels called nadis, cycling through the body in rhythmic patterns. When balanced, these rhythms sustain health and consciousness. Yoga and meditation practices aim to control and harmonize these flows. The parallel to 3i Atlas's magnetic rhythm is striking. A force flowing through the object in cycles, maintaining structure, sustaining a state that should be unsustainable. On November 8th, researchers at the Arecibo Observatory's successor facilities detected another layer to the magnetic phenomenon. Low-frequency radio emissions peaking at exactly 12.7 megahertz, synchronized with the magnetic pulses. The radio waves weren't modulated or structured, nothing that resembled communication, but they were there, repeating with the same 3.9-minute period. In plasma physics, this is called cyclotron radiation, emitted when charged particles spiral along magnetic field lines. The frequency of cyclotron radiation depends on the strength of the magnetic field and the mass of the particles. By analyzing the radio signature, physicists could infer the internal magnetic environment of 3i Atlas. What they found was unexpected. The field inside the object appeared to be much stronger than the external field, possibly thousands of times stronger, as if the visible magnetic halo was just the outermost layer of a much more intense internal field structure. This implies compartmentalization. Layers, an external shell and an internal core with different properties. The Greek philosopher Empedocles taught that reality consists of 4 elements: earth, water, air, fire, bound and separated by 2 cosmic forces, love and strife. Love brings elements together into harmony. Strife tears them apart into chaos, but both forces he taught operate in cycles. The universe breathes, expanding and contracting in eternal rhythm. Perhaps 3i Atlas in its own incomprehensible way was demonstrating that same principle. A cycle of magnetic force holding plasma together, then releasing it. Absorption and emission, contraction and expansion, a cosmic breath. By mid-November, the magnetic rhythm had become so predictable that scientists could forecast the next pulse to within seconds. Teams began using it as a timing reference, joking darkly that 3i Atlas had become the most precise clock in the solar system, but precision implies control. Clocks don't keep time by accident. They keep time because something regulates them, a pendulum, a quartz crystal, an atomic transition. What was regulating 3i Atlas? One hypothesis proposed internal rotation. If the object had a layered structure with regions rotating at different rates, the friction between layers could generate rhythmic magnetic fluctuations. Earth's dynamo works on a similar principle, though over much longer timescales. Another theory suggested resonance. Perhaps the object's physical structure had a natural oscillation frequency, and the energy absorbed during perihelion excited that resonance, causing it to ring like a bell struck by solar radiation. Both explanations were plausible, but incomplete. Neither explained why the rhythm was so stable, so immune to external perturbation. The solar wind varies constantly, buffeting everything in its path with gusts and lulls. Yet 3i Atlas maintained its pulse unchanged. In the traditions of indigenous Australian cultures, the land is crisscrossed by song lines, invisible paths that connect sacred sites. The ancestors, it's believed, sang the world into existence, and their songs persist in the land itself, a vibrational memory that guides those who know how to listen. Perhaps objects, too, carry vibrational memory. Perhaps 3i Atlas, forged in the death of a star billions of years ago, retain the rhythm of that ancient cataclysm, and perhaps passing through the sun awaken that memory, setting it ringing once more. The magnetic heartbeat continued as the object drifted farther from the sun, fainter now, harder to detect, but still there, still pulsing. A reminder that somewhere in the cold of space, this dark mirror of fused matter carried within it a rhythm that refused to stop. Some things survive, not by resisting the universe, but by harmonizing with it. By finding the right frequency and sustaining it against all odds. 3i Atlas had found its frequency, and it was broadcasting it into the void, one pulse at a time, a beacon of order in the entropic dark. In the sterile conference rooms of NASA's Jet Propulsion Laboratory, a debate began that would fracture the scientific consensus around 3i Atlas. The question was simple, but the implications were staggering. How does an object gain mass without gaining volume? The trajectory calculations were unambiguous. Using data from multiple tracking stations, Goldstone in California, Canberra in Australia, Madrid in Spain, analysts measured tiny perturbations in 3i Atlas's path. These deviations were consistent with a gravitational signature approximately 8% stronger than pre-perihelion models predicted. 8%. That's not a rounding error. That's billions of tons. Yet optical and radar observations showed the object's physical dimensions remained unchanged. Its silhouette against background stars was identical. Its radar profile revealed no expansion. Same size. More mass. In classical physics, this is impossible. Mass and volume are linked through density, but adding mass requires either compressing the existing volume or adding material. Compression at this scale would produce visible deformation or fragmentation. Adding material should produce observable growth. 3i Atlas did neither. Dr. Andrea Milani's team at the University of Pisa ran the orbital mechanics through 3 independent software suites, checking for computational errors. Every simulation returned the same result. Post-perihelion, the object's gravitational influence was stronger. It pulled harder on passing space dust on distant asteroids, even infinitesimally on the spacecraft observing it. The density had increased. The only question was how. One hypothesis emerged from the plasma absorption event. If 3I Atlas truly captured solar matter during those critical seconds, that material had to go somewhere.
Perhaps it didn't coat the surface like dust. Perhaps it penetrated deeper, filling internal voids or integrating into the existing structure. Think of a sponge. It has volume determined by its physical size, but it's mostly empty space. When you submerge it in water, it gains mass without changing external dimensions. The water fills the pores. Could 3I Atlas be porous? Could it have internal cavities that the absorbed plasma filled and sealed? The radar data partially supported this. Sound waves traveling through solid materials produce echoes that reveal internal structure. Seismologists use this technique to map Earth's layers, crust mantle, outer core, inner core, each with different densities that reflect seismic waves differently. When radio waves were transmitted toward 3I Atlas, the echoes that returned were extraordinarily flat. No internal reverberation, no hints of cavities or layers, just a single uniform return from the surface. This suggested two possibilities. Either the object was completely solid, a homogeneous mass with no internal structure, or the internal structure was so perfectly ordered that waves passed through without scattering like light through a flawless crystal. Both options strained credulity. Natural objects are messy. Asteroids are rubble piles, loosely bound collections of rock and metal held together by weak gravity. Comets are icy conglomerates, riddled with voids and cracks. Even metallic bodies like iron meteorites contain impurities, grain boundaries, and internal stresses. Perfect homogeneity doesn't occur in nature. It's an engineering goal. Yet here was an object exhibiting precisely that quality, perfect internal uniformity that absorbed radio waves without echo, suggesting either solid perfection or structured emptiness filled with something that couldn't be distinguished from the surrounding material. The ancient practice of lost wax casting provides an interesting parallel. Bronze sculptors create a wax model, encase it in clay, then pour molten metal into the space left when the wax melts away. The result appears solid, but is often hollow, with the metal forming a shell around emptiness. The finished sculpture weighs less than a solid bronze piece would, but from outside it appears identical. Only by tapping it, listening for the ring of hollow versus solid, can you detect the difference. Was 3I Atlas hollow once? Did the absorbed plasma fill that hollowness, adding mass without changing shape? Dr. Dante Loretta, principal investigator of NASA's OSIRIS-REx asteroid sample mission, offered another perspective. His team had studied asteroid Bennu in exquisite detail and found it to be far less dense than expected, a loosely packed collection of boulders with vast spaces between. If 3I Atlas had a similar structure initially, the intense heat and pressure of perihelion could have caused internal collapse.
The spaces between fragments would compress, particles would fuse, and the entire body would densify like compacted snow turning to ice. But this process should be violent. It should produce surface fractures, jets of escaping gas, visible signs of internal readjustment. Bennu sheds pebbles constantly as thermal expansion and contraction stress its already fractured structure. 3I Atlas showed no such activity. Its surface remained intact, its rotation stable. If compression occurred, it happened smoothly, uniformly, without the chaos that usually accompanies structural collapse. That smoothness is what troubled the analysts most. In metallurgy, there exists a process called hot isostatic pressing, where metal powders are heated under extreme pressure until the particles fuse into a solid mass with near-perfect density. The process requires precise controlled temperature, pressure, time, all carefully managed to avoid flaws. The result is a material stronger than castings, denser than forgings, with properties that exceed natural materials.
Was 3i Atlas subjected to a natural version of hot isostatic pressing? Did the sun provide the heat, while the object's own magnetic field provided the pressure the plasma absorption would supply both energy and material? The magnetic pulsations could act as compression waves, squeezing the internal structure in rhythmic pulses, allowing particles to settle and fuse. Over several hours of perihelion passage, this could transform a porous body into a dense, coherent mass. This is speculation, but it fits the observations. It explains the mass gain, the internal uniformity, the surface smoothness. It accounts for the timing, the transformation happening precisely when heat pressure and magnetic activity peaked simultaneously. But it also requires something troubling: coordination. Random processes don't coordinate. They don't synchronize heat magnetism and compression to achieve optimal results. They produce chaos, not perfection. The ancient Greek myth of Hephaestus, god of the forge, describes him crafting divine armor and weapons in his volcanic workshop. The stories emphasize his skill at knowing exactly when to heat the metal, when to strike, when to quench. Perfect timing produces perfect results. Was 3i Atlas forged through cosmic serendipity, the right materials in the right place at the right time? Or did something about its internal structure predispose it to transform this way? Like a seed designed to germinate only under specific conditions, the density paradox remains unresolved. The mass increase is documented. The lack of volume change is confirmed. The mechanisms that could explain both remain theoretical. But one fact is undeniable. 3i Atlas emerged from perihelion not just intact, but improved. Stronger, denser, more coherent. As if the sun hadn't tested it. The sun had perfected it. And that more than any single anomaly is what keeps scientists awake at night. Because if an object can use stellar radiation to upgrade itself, the implications ripple outward into uncomfortable territory. Territory where the line between natural and intentional begins to blur. Silence, in the language of physics, is information. When radar operators at the Goldstone Deep Space Communications Complex directed their instruments toward 3i Atlas in early November, they expected the usual scatter of echoes that paint a picture of an object's surface texture, rotation, and internal structure. What they received instead was something that made them check their equipment 3 times. Silence. Not the silence of absence, the radar energy was reaching the target, but the silence of absorption. The radio waves struck 3i Atlas and vanished, swallowed into its structure with almost no return signal except from the very outer boundary. Marina Brozovic, who has mapped hundreds of near-Earth objects using radar, described it in her observation notes. It's like shouting into a cave and hearing no echo. Not even a whisper, just your voice disappearing into darkness. Natural objects don't behave this way. Rock scatters radio waves chaotically because its structure is irregular crystals of different sizes void, space's mineral variations. Metal reflects strongly because electromagnetic waves bounce off conductive surfaces. Ice transmits and refracts, creating complex echo patterns. Atlas did none of these. It absorbed. The technical term is anomalously low radar cross-section, but that's scientific understatement. The object's radar signature was so weak it barely registered above background noise. For comparison, an object of similar size made of iron should reflect approximately 10,000 times more energy. This implies one of 2 scenarios, both unsettling. First possibility. The interior is structured in a way that traps electromagnetic waves. Like an anechoic chamber lined with sound-absorbing foam, perhaps the internal geometry creates destructive interference where incoming waves cancel themselves out through reflection and counter-reflection. This requires precise internal architecture angles, surfaces, cavities, arranged to achieve acoustic silence at radio frequencies. Such structures exist in human engineering.
stealth aircraft. Radio quiet rooms, specialized materials designed to be invisible to radar. In nature, never observed. Second possibility, the material itself is absorptive. Certain compounds can convert electromagnetic energy into heat or other forms, essentially acting as a sponge for radio waves. Carbon nanotubes do this. Metamaterials engineered at molecular scales can achieve near-perfect absorption. But again, these are manufactured materials created through deliberate design and fabrication. They don't form randomly in space. Yet here was 3I Atlas exhibiting radar properties that suggested either internal architecture or material science beyond what natural processes typically produce. The Tibetan singing bowls used in Buddhist meditation offer an interesting cultural parallel. These metal bowls, when struck or rubbed, produce deep harmonic tones that seem to emanate not from the surface, but from within the metal itself. The sound resonates through the structure, sustained and amplified by the geometry and composition of the bowl. But more intriguing is what happens when two bowls of precisely matched frequency are placed near each other. Strike one and the other begins to vibrate sympathetically, absorbing the sound energy and transforming it into its own resonance. The bowls are not communicating. They're synchronizing through physical law, resonant frequency coupling. Could 3I Atlas's interior be structured to resonate at specific frequencies, absorbing incoming radio energy the way a tuned cavity absorbs sound? The radar silence had another characteristic that deepened the mystery. It wasn't constant. Over the course of the observation campaign spanning several weeks, operators noticed the absorption varied slightly in a rhythmic pattern. Every 3.9 minutes, matching the magnetic pulse cycle, the radar return would strengthen fractionally before fading again, as if the object's transparency to radio waves was modulating, opening and closing like an iris. That variation implies active structure. Something inside was changing state, alternating between more absorptive and less absorptive configurations. This could be explained by internal material flowing or rotating, presenting different cross-sections to the incoming radar. But the precision of the timing, locked to the magnetic rhythms, suggested the changes weren't random turbulence. They were coordinated. The Gothic cathedrals of medieval Europe demonstrate how architecture can manipulate sound. Notre Dame, Chartres, Canterbury. These structures were designed not just for visual grandeur, but for acoustic perfection. A whisper in one corner can be heard clearly across the nave through reflection and channeling of sound waves. The architects understood resonance frequency and geometry long before physics formalized these concepts. They created buildings that absorbed certain frequencies and amplified others, shaping the sonic environment to enhance sacred rituals. What if 3I Atlas possessed a similar relationship with electromagnetic radiation? What if its internal structure, whether designed or evolved through unknown processes, created specific resonances that managed energy absorption? This would explain the radar silence. It would explain the modulation. It would explain why the object survived perihelion by absorbing destructive radiation rather than reflecting it back into its own structure. Absorption as survival strategy. NASA's Planetary Defense Coordination Office took particular interest in these findings. Their mission is to track and characterize potentially hazardous asteroids. Radar is their primary tool. It reveals rotation rates, shapes, surface features, and most critically, trajectories with precision that optical telescopes cannot match. But an object that doesn't return radar signals is effectively invisible to their primary detection method. If 3I Atlas represented a class of objects with similar absorptive properties, the implications for planetary defense were troubling. How many dark, silent bodies might be passing through the inner solar system undetected because they don't scatter our radio waves? The question remains theoretical for now. 3I Atlas is the first known object exhibiting this characteristic.
Whether it's unique or representative of a hidden population is unknowable without discovering more. But the possibility hangs in the air like smoke. By late November, after exhausting standard radar techniques, the team attempted a different approach, bistatic radar. Instead of bouncing signals off the object and catching the return, they transmitted from one location while a distant receiver listened from a different angle, hoping to catch scattered energy that didn't return to the source. The results were marginal. Faint signals were detected, but they revealed only the object's motion and approximate size. The internal structure remained opaque, hidden behind whatever mechanism was swallowing the electromagnetic energy. One researcher speaking off the record compared it to the event horizon of a black hole, a boundary where information goes in but doesn't come out. Of course, 3I Atlas wasn't a black hole. Its gravity was normal, its mass modest. But the analogy captured the frustration an object that refuses to reveal its interior. In the mythology of ancient Sumer, the goddess Ereshkigal ruled the underworld Irkala, the land of no return. Those who descended could not come back unchanged. Information entered but didn't escape in the form it went in. The radar silence of 3I Atlas evoked that same quality. Energy went in. Silence came out, and whatever transformation occurred within remained hidden from our instruments. As the object continued its outbound journey, the radar observations became increasingly difficult. Distance angle and the weakening signal combined to push detection below useful thresholds. By mid-December, active radar tracking ceased. The silence that began as a scientific puzzle ended as a practical barrier. We could no longer probe the interior. We were left with surface observations, optical infrared spectroscopy, all of which showed only the transformed outer shell. Whatever lay beneath, whatever structure or composition gave 3I Atlas its anomalous properties would remain speculative, hidden, perhaps deliberately so. The final radar observation came from Arecibo's successor facility in Puerto Rico on December 3rd. The transmission was powerful, the aim precise. The return was faint but clear. The object's boundary and nothing more. The operator wrote in the log, "Target acquired but non-responsive to internal interrogation. Structure remains acoustically dark." Acoustically dark, the phrase captures it perfectly. An object that exists, that can be seen and tracked, but that refuses to echo our questions back to us. In a universe where almost everything reveals itself to patient observation, 3I Atlas chose silence, and in that silence perhaps was its most profound statement that some things carry their secrets inward, holding them in darkness where no signal can reach, no observation can penetrate. The universe, it seems, still knows how to keep mysteries. Winter arrived in Earth's northern hemisphere, but for 3I Atlas summer lingered. Weeks after departing, the sun's proximity long passed. When any natural body should have cooled to ambient space temperature, the object continued radiating infrared warmth. Not dramatically, no glowing surface or visible thermal plume, but steadily, measurably, impossibly. Dr. Lori Feaga at the University of Maryland tracked the cooling curve using data from the Spitzer Space Telescope successor and ground-based infrared arrays. Natural cooling follows a logarithmic decay, rapid at first, then slowing asymptotically toward equilibrium with the environment. 3I Atlas followed a different pattern. Its temperature dropped initially as expected. Then it plateaued, holding steady at approximately 240 Kelvin, about minus 33 Celsius for days, before dropping again to a new plateau. The curve wasn't smooth. It was stepped like a staircase descending. Each plateau lasted approximately 90 minutes, precisely half the magnetic pulse period. Then the temperature would drop to the next level and hold there. Stable. Controlled. Thermal regulation in space is a challenge human engineers struggle with constantly. Spacecraft require radiators, heat pipes, and carefully designed surfaces to manage temperature. Too hot and electronics fail. Too cold and lubricants freeze.
The James Webb Space Telescope, for instance, uses a massive multi-layered sun shield to keep its instruments at a constant 40 Kelvin. Without active management, temperatures in space fluctuate wildly between sunlight and shadow. 3I Atlas was maintaining temperature stability without any apparent mechanism to do so. No visible radiators, no attitude adjustments to expose different surfaces, just steady thermal control that suggested internal energy management. The infrared imaging revealed another detail: hotspots, small regions across the surface that glowed slightly warmer than their surroundings. These weren't static. They migrated, drifting from the equatorial regions toward the poles in regular patterns. The migration took exactly 90 minutes to complete. One hotspot would appear near the equator, move northward or southward along a curved path, then fade as it neared the pole. Minutes later, a new hotspot would appear and repeat the journey. Dr. Robert Hurt, who created the visualization maps, described it like watching heat flow through veins, or electrons moving through a circuit, too organized to be random convection. In living organisms, temperature regulation is called homeostasis. Mammals maintain constant internal temperature through complex feedback systems: shivering when cold, sweating when hot, redirecting blood flow to conserve or release heat. The mechanisms are biological, but the principle is thermodynamic. Stability requires energy expenditure. 3I Atlas appeared to be achieving homeostasis through unknown means. It was spending stored energy to maintain thermal equilibrium rather than passively radiating heat into the void. This implies that maintaining a specific temperature served some purpose. But what purpose does temperature serve for an inert object? In materials science, temperature determines phase states: solid, liquid, gas. It governs chemical reaction rates, electrical conductivity, structural integrity. Many advanced materials only exhibit their special properties within narrow temperature ranges. High-temperature superconductors, for instance, lose all electrical resistance only when cooled below critical temperatures. Certain alloys become superelastic or change crystal structure at specific thermal thresholds. Could 3I Atlas be maintaining temperature to preserve some property acquired during perihelion? Perhaps the metallic glass surface, the internal structure, or the magnetic field generation required staying within a specific thermal range to remain stable. That would explain the stepped cooling curve. Instead of releasing heat continuously, the object might be regulating its descent toward equilibrium, pausing at temperatures where its structure remained optimal. The ancient Chinese concept of qi describes life energy flowing through the body along channels called meridians. Traditional medicine teaches that maintaining balanced qi flow prevents illness and sustains vitality. When flow is blocked, or excessive pain and disease result. Acupuncture, qigong, and tai chi all aim to regulate this flow, keeping energy moving through the body at the right rate in the right patterns. The thermal behavior of 3I Atlas evoked that same principle: energy flowing through internal channels, regulated and balanced, maintaining a state of dynamic equilibrium, not stasis but sustained organization. By December, the infrared signature had weakened considerably. Distance and continued cooling made observation increasingly difficult. But even at the detection threshold, the pattern persisted: faint hotspots still migrating in their prescribed paths, temperature still plateauing at regular intervals. Whatever mechanism sustained this behavior showed no signs of depletion. The energy absorbed during perihelion, stored somehow within the object's structure, was being released with extraordinary efficiency. Dr. Seamus Blackley, a thermodynamicist at Cambridge, calculated the energy budget. The amount of heat 3I Atlas absorbed during perihelion passage, even accounting for its dark surface, should have been radiated away within days of leaving the sun's vicinity.
Yet weeks later it still glowed. The only explanation: internal storage. The absorbed energy hadn't immediately converted to surface heat. It had been trapped deeper, perhaps in molecular bonds, magnetic fields, or phase change materials that released energy slowly over time. This is speculation he noted carefully, but the math suggests the object functions as a thermal capacitor absorbing rapid energy input and distributing it as slow output.
Capacitors store electrical charge, batteries store chemical energy, flywheels store kinetic energy. Each is a designed system for managing energy across time, taking in energy quickly when available and releasing it gradually when needed. Was 3i Atlas doing the same with thermal energy? Not as a machine, but as a structure whose very composition allowed this behavior. The Ayurvedic medical tradition of India speaks of the three doshas, vata, pitta, kapha, fundamental energies that govern all physiological processes. Pitta associated with fire and transformation must be balanced carefully. Too much and the body overheats, too little and metabolism slows. Health requires maintaining pitta in dynamic balance, neither excessive nor deficient. 3i Atlas was demonstrating pitta balance on a cosmic scale. It had touched fire-absorbed heat and now was releasing it with the measured pace of a living system, preventing overheating. The thermal memory, the object's refusal to quickly forget the sun's touch, suggested something profound. Perhaps matter, when subjected to extreme conditions, doesn't simply return to its previous state. Perhaps it retains memory of the transformation encoded in its structure, releasing that memory gradually through thermal emission. Like trauma held in the body, the sun's intensity remains stored within 3i Atlas, emerging slowly as heat and light over weeks and months. Whether this was a natural property of its composition or evidence of something more designed remained debatable. But the observation was clear: the object wasn't passively cooling. It was actively managing its thermal state. As winter deepened on Earth and 3i Atlas drifted past Mars's orbit, the infrared telescopes maintained their watch. The hot spots continued their migration. The temperature held its stepped decline. The stored summer refused to release its hold. Somewhere in the dark between worlds, the object carried fire within it. Not visibly, not violently, but undeniably. A memory of the sun sustained against entropy's demand for equilibrium, a quiet defiance of the cold. In the ancient world, halos were reserved for gods and saints. Art from Byzantine mosaics to Renaissance paintings depicted divine figures surrounded by radiant circles, symbols of spiritual power. Otherworldly presence, the visible manifestation of the sacred. 3i Atlas wore a halo, not metaphorically, literally. In the first clear images captured after perihelion, a faint, luminous envelope surrounded the dark body of the object. Spectroscopic analysis identified it immediately: ionized plasma, primarily hydrogen and oxygen, glowing in the characteristic blue-violet wavelengths of highly energized particles. Plasma halos aren't uncommon around comets. As ice sublimes and gas expands, solar ultraviolet radiation strips electrons from atoms, creating glowing comas and tails that stretch millions of kilometers. But 3i Atlas's halo was different. It didn't expand. It didn't stream away in the solar wind. It held. The envelope maintained a consistent elliptical shape, roughly 50 kilometers across at its widest point, rotating with the object's slow spin. The boundary was sharp, not diffuse. Inside the ellipse, plasma density was elevated. Outside normal solar wind, something was containing it. Dr. James Bauer at NASA's Planetary Science Institute noted that the only force capable of confining plasma in a stable structure is magnetic. The halo's persistence weeks after perihelion meant magnetic field lines were still active, still trapping and holding charged particles. But the energy required to maintain such confinement shouldn't persist this long. Magnetic fields, generated by temporary induction, like when lightning magnetizes objects, fade within hours or days as internal currents dissipate. This one wasn't fading. The plasma itself showed unusual characteristics. Its density varied rhythmically with the same 3.9-minute magnetic pulse cycle. When the field strengthened, the halo brightened. When it weakened, the glow dimmed. But even at minimum brightness, the structure remained visible, a ghost-light cocoon that moved through space with its host.
In Egyptian funerary art, the Shen ring appears frequently a circle or oval of rope, symbolizing eternity protection and divine encirclement. The pharaohs and gods are often shown holding or standing within the Shen, representing their eternal nature. The hieroglyph itself means to encircle, suggesting that boundaries contain and preserve what lies within. 3i Atlas's plasma halo evoked that same symbolism. The object transformed by fire now held around itself a protective circle that separated it from the surrounding environment. Not isolation, but differentiation. Inside, the halo conditions were different, calmer, more stable. Outside, the chaos of the solar wind continued unchanged. Dr. Carol Patti, a magnetosphere physicist at the University of Oregon, compared it to Earth's magnetosphere. Our planet's magnetic field carves out a bubble in the solar wind, a protective region where atmospheric particles are held close shielded from stripping by solar radiation. Mars lost its magnetosphere billions of years ago, and with it much of its atmosphere. The solar wind eroded the thin air layer by layer, leaving the planet cold and dry. A magnetosphere is a shield, a boundary that determines which matter stays and which escapes. 3i Atlas had created or activated its own shield, mobile, self-contained, and apparently self-sustaining. The color of the halo shifted subtly over time. In the first post-perihelion images, it glowed electric blue. By mid-November, the hue had deepened toward violet. By December, hints of red appeared at the outer edges. Color in plasma emission reflects the energy states of ions. Blue indicates high-energy excitation. Red suggests lower energy transitions. The spectrum was cooling the plasma, losing energy gradually. But unlike expanding cometary tails where plasma cools and fades rapidly, this halo cooled with controlled grace. The color change was gradual, smooth, following a predictable spectral sequence. In Hindu cosmology, the Sudarshana chakra is described as a spinning disk of energy that protects the god Vishnu. It's depicted as both weapon and shield, a boundary that can't be crossed by destructive forces. The texts describe it as self-aware, in some mystical sense, responding to threats without conscious direction, maintaining balance through its own inherent nature. Myth speaks in symbols, but perhaps those symbols pointed toward real phenomena, objects surrounded by protective fields, structures that shield themselves through electromagnetic boundaries. By late November, instruments detected something unexpected within the halo structure. The plasma wasn't uniformly distributed. It formed subtle filaments, thread-like concentrations of higher density that spiraled around the object. These filaments rotated faster than the object itself, suggesting they were following magnetic field lines that twisted through the plasma, organizing it like iron filings around a bar magnet. Dr. William Farrell at NASA Goddard created magnetic topology models based on the observed filaments. The best fit configuration resembled a flux rope magnetic field lines wound into a helical structure, stable and self-reinforcing. Flux ropes occur naturally in solar flares and planetary magnetospheres, but they're typically short-lived, collapsing within minutes to hours. They require constant energy input to maintain coherence. Yet 3i Atlas's flux rope persisted for weeks, suggesting the energy input wasn't external. It was coming from within. The Celtic spiral symbol appears across ancient Europe, carved into stone monuments thousands of years old. Triple spirals like those at Newgrange in Ireland suggest cycles, energy flow, and interconnection. Celtic scholars debate their meaning, but many interpret the spirals as representations of life force energy that turns inward and outward, simultaneously sustaining itself through circular flow. The plasma filaments spiraling around 3i Atlas followed that same pattern. inward toward the object outward, along field lines cycling in perpetual motion. On December 8, the ESA's solar orbiter passed within optimal range for detailed plasma measurements. The spacecraft's instruments sampled the solar wind upstream and downstream of 3I Atlas's position, comparing conditions. Upstream normal turbulence, chaotic fluctuations in particle density, and magnetic field strength characteristic of the solar wind. Downstream, in the wake of the object, the turbulence had diminished. The plasma was calmer, more laminar, as if passing through the halo had organized the solar wind, smoothing its chaos into coherence. This wasn't just a shield deflecting particles, it was a filter, a structure that interacted with the solar wind and altered its properties.
Dr. Angelos Vorlidis, a heliophysicist studying the data, found the effect analogous to how the Earth's magnetosphere creates a bow shock, a standing wave in the solar wind upstream of the planet. But typically bow shocks are turbulent, not calming. The halo around 3I Atlas appeared to be reducing chaos rather than creating it. An anti-bow shock, if such a thing could exist. The implications stirred quiet discussion in the community. If an object could calm plasma turbulence, it might be doing so by absorbing the chaotic energy, converting turbulence into organized flow. That requires a mechanism, something that recognizes disorder and corrects it. In thermodynamics, this is called a Maxwell's demon, a hypothetical entity that could violate entropy by sorting particles, creating order from disorder. James Clerk Maxwell proposed it as a thought experiment, showing the statistical nature of the second law of thermodynamics.
Real Maxwell's demons can't exist because sorting requires energy expenditure. You can't beat entropy without paying a cost. But what if 3I Atlas wasn't beating entropy? What if it was using the energy of chaos itself to power its ordering mechanism, feeding on turbulence to maintain its stable halo that would make it not a demon but an engine, a structure that extracts useful work from environmental disorder? The halo continued to glow faintly into January 2026, visible only to the most sensitive instruments. The plasma density had dropped significantly, but the structure remained invisible to the eye, but present in magnetometer readings. Like the Cheshire Cat's smile remaining, after the cat has faded, the magnetic structure persisted even as the visible glow diminished.
What does it mean for an object to create and maintain a boundary around itself? To hold a region of space distinct from its surroundings? In biology, we call it a cell membrane, the fundamental barrier that separates life from non-life self from environment. In sociology, we call it identity, the boundaries we maintain that define who we are versus who we are not. In metaphysics, it's the question of self, what constitutes an individual entity, in a universe where everything is connected. 3I Atlas had demonstrated boundary. It wasn't just an object moving through space. It was an object maintaining a distinct region around itself, preserving conditions different from the background, holding a structure that required energy and organization. Whether through natural magnetism or something more, it had achieved what philosophers call individuation, the state of being a discrete entity, separated from but interacting with the whole. The plasma halo was its membrane, its skin,
its statement of identity. And as it drifted farther into the dark, that glow remained faint, enduring, marking where one thing ended and another began, a luminous signature of selfhood. One of the fundamental assumptions in astronomy is that an object's composition remains constant. Spectrography allows us to determine what an asteroid or comet is made of based on the wavelengths of light it reflects or emits. With 3I Atlas, that assumption collapsed. Observations before perihelion, when the object was discovered in July 2025, showed spectral lines consistent with metallic minerals, primarily iron-nickel alloys, with traces of silicates. Standard fare for a dense interstellar fragment, perhaps the remnant core of a destroyed planet. By November, after perihelion, those lines had shifted. New absorption features appeared in wavelengths associated with chromium and molybdenum elements present in trace amounts before, but now prominent.
More concerning emission lines showed compounds that shouldn't be thermodynamically stable together: refractory ceramics alongside volatile hydrocarbons, oxidized metals next to reduced sulfides, combinations that would normally react, neutralize, or separate under high temperatures. Yet here, they coexisted on the same surface. Dr. Lucy Lim at NASA's Goddard Space Flight Center ran the spectral data through every mineralogy database available. No match existed for the post-perihelion composition. The closest terrestrial analogs were synthetic materials, engineered alloys, and ceramic metal composites created under extreme controlled laboratory conditions, materials that don't form in nature. She was careful in her published analysis. The spectral signature suggests high-temperature processing created surface compounds of unusual complexity. Natural processes cannot be ruled out, but comparable formation mechanisms are not currently known.
Natural processes cannot be ruled out. The phrase became a refrain across the literature, a way of saying we don't understand without admitting impossibility. The ancient practice of Damascus steel forging illustrates how material properties can be transformed through precise manipulation of heat and composition. Blacksmiths in medieval Syria created blades of legendary sharpness and flexibility by folding steel repeatedly, incorporating carbon in precise patterns, heating and cooling in cycles. The technique was lost centuries ago. Modern metallurgists have partially reconstructed it, but the original Damascus steel's exact composition remains a mystery because the material's properties emerge from process, not just ingredients. Perhaps 3I Atlas underwent something similar, a transformation through process that created emergent properties, not predictable from its starting materials. But Damascus steel required a blacksmith. The spectral shifts weren't uniform across the surface. High-resolution imaging from the Hubble Space Telescope revealed patterns. Regions of different composition formed geometric arrangements, hexagonal arrays in some areas, linear striations in others. At first, researchers attributed this to crystal structure. Many minerals naturally form geometric patterns as they cool. Basalt columns create hexagons. Salt crystals form cubes. Snowflakes grow dendritic fractals. But the scale was wrong. The patterns on 3I Atlas repeated every few meters, too large for molecular crystallization, too uniform for random cooling stresses. Dr. Bethany Ehlman at Caltech noted that the hexagonal patches were all approximately the same size, averaging 4.2 meters across, and distributed in a grid-like pattern with spacing that appeared deliberate. Deliberate is a dangerous word in planetary science. It implies intention, planning, design. No natural process is deliberate. Natural processes are blind, following physical law without foresight or goal. Yet here was a distribution pattern that matched more closely to engineered tessellation, the efficient packing of repeated shapes to cover a surface. In Islamic geometric art, tessellation reaches profound sophistication. The Alhambra in Spain, the mosques of Isfahan, these structures demonstrate how repeated geometric forms can tile a surface endlessly without gaps, creating patterns of mesmerizing complexity from simple shapes. The mathematicians who designed these patterns understood symmetry repetition and the principle that simple rules, applied consistently, create emergent beauty. Was 3I Atlas's surface demonstrating mathematical elegance? Or was it coincidence that the compositional variations happened to fall into regular patterns? The question split the research community. The conservative view held that during perihelion heating, the surface partially melted.
As it cooled, thermal contraction created a network of cracks similar to mud drying in a desert. These polygonal crack patterns are well documented on planetary surfaces from Earth to Mars to Europa. The spacing and regularity in this view arose from uniform thermal stress across a uniform material. The problem, 3I Atlas's surface wasn't uniform. The spectral data showed compositional diversity, different materials in different patches. Yet the geometric pattern persisted regardless of composition. That suggested the pattern came first, determining where different materials would settle, not the other way around. The alternative view, spoken quietly in departmental hallways, was that the internal structure of 3I Atlas included some kind of scaffolding, perhaps microscopic channels or voids arranged in geometric patterns that guided material deposition during the heat and cooling of perihelion. If such structure existed, it would act as a template like the honeycomb in a beehive, where wax fills the hexagonal cells created by the bee's construction. But what natural process creates internal templates? Dr. Christopher Glein at the Southwest Research Institute proposed a speculative model: layered materials with different thermal expansion coefficients. When heated, they expand at different rates, creating stress patterns. When cooled, they contract back, but the stress pattern remains guiding crystallization. It's plausible for simple structures, but the complexity observed on 3I Atlas multiple materials, multiple patterns all coordinated, strained the explanation. The alchemical tradition spoke of the magnum opus, the great work of transformation. The process had stages: calcination, burning, dissolution, breaking down, separation, purifying, conjunction, recombining, and finally coagulation, solidifying into perfected form. The goal wasn't just to transform one substance into another, but to perfect it, to remove impurities, balance opposites, and create something that embodied ideal properties. Medieval alchemists cloaked their work in symbolic language, making it difficult to separate literal chemistry from spiritual metaphor. But many were genuine experimentalists, discovering processes that later became foundational chemistry. Perhaps they intuited something true, that matter subjected to transformative processes doesn't merely change randomly. It evolves towards states of lower energy, greater stability, emergent order. 3I Atlas had undergone calcination in the solar furnace. What emerged was not chaos, but pattern, not random distribution, but geometric organization. Whether through physical laws we don't yet understand, or through pre-existing internal structure, the object had achieved a state that resembled completion. The emerald tablet attributed to the legendary Hermes Trismegistus contains a famous axiom: separate the earth from the fire, the subtle from the gross, gently and with great ingenuity. The instruction suggests that transformation requires not just heat, but intelligence in its application, knowing when to apply force, when to allow cooling, how to guide matter toward its ideal form. No one was suggesting 3I Atlas possessed intelligence, but its transformation had proceeded as if guided by principles that ensured optimal outcome. By January, as the object moved beyond easy observation range, the spectral lines began to stabilize. The shifting that characterized November and December slowed. The composition appeared to be settling into a new equilibrium. Whatever reorganization had been triggered by perihelion was completing itself. The surface was no longer actively changing. It had found a stable configuration. That stability suggested the transformation wasn't ongoing decay, but had reached a destination, a point of maximum order, given the materials and energy available. In thermodynamics, this is called a local minimum, a stable state that a system naturally evolves toward. Water flows downhill to the lowest point. Magnets orient to minimize field energy. Systems seek stability, but simple systems have simple minima. Complex systems, especially those with multiple interacting components, can have highly structured, organized local minima that appear designed. Snowflakes form hexagonal patterns, not because they're designed, but because ice crystal geometry makes hexagons the most stable configuration. The beauty and complexity emerge from simple rules applied fractally. Was 3I Atlas's geometric surface pattern similar, complexity emerging from simple underlying principles? Or was it that, and something more, principles embedded not in universal law, but in the specific structure of this specific object. A structure that predisposed it to transform in precise ways when exposed to stellar fire we may never know. The object is fading from our ability to observe in detail. What remains are images, spectral data measurements, records of an object that defied categorization by changing its very nature before our eyes. A shapeshifter, a transformer, an interstellar chameleon that wore one face entering the sun's domain and another leaving it. Whether the new face was a mask or a revelation remains the deepest question of all. Time is the hidden variable in every observation, the axis along which all events unfold. In the case of 3I Atlas, time revealed patterns that should not exist. The breakthrough came from a collaboration between NASA's Heliophysics Division and ESA's Solar Science Archive. Researchers overlaid the object's behavior timeline against solar activity logs, searching for correlations. What they found was disturbing. Approximately 8 to 11 minutes before each significant solar event flares, coronal mass ejections, magnetic field reversals. 3I Atlas's magnetic field would strengthen, not dramatically, just a 2-3% increase in intensity, but consistently. The timing was precise enough to be measured but impossible to explain by conventional causation. Solar events are driven by complex magnetic reconnection processes in the sun's atmosphere. The energy builds over hours or days, then releases suddenly. From the sun to 3I Atlas's position, light and all electromagnetic radiation travels in 8-11 minutes, depending on the exact distances involved. That means any information about the impending solar event takes 8-11 minutes to reach the object.
Yet 3I Atlas appeared to be responding before the light could arrive. Faster-than-light communication is impossible according to special relativity. Einstein's equations are unambiguous. Information cannot travel faster than light in vacuum. No force, no signal, no influence can propagate superluminally without violating causality itself. 3 possibilities remain. First, the correlation is coincidence. With thousands of magnetic measurements and hundreds of solar events, statistical clustering could create apparent causation where none exists. Dr. Janet Luhman at UC Berkeley performed rigorous statistical analysis, applying multiple testing corrections and randomization controls. The correlation held. Probability of coincidence less than 0.3%. Not impossible, but unlikely enough to demand explanation. Second, 3I Atlas is responding to precursor signals that arrive before the main event. The sun emits particles, magnetic waves, even neutrinos, that could carry information ahead of the photons we use to detect flares. High-energy particles from solar events do reach space before the bulk of electromagnetic radiation. If 3I Atlas possessed extreme sensitivity to these precursors, it might detect them and respond accordingly. But particle speeds are well characterized. Even relativistic particles travel at or slightly below light speed. The time advantage would be seconds, not the observed 8-11 minutes, unless neutrinos were involved. Neutrinos interact so weakly with matter that they pass through the sun almost unimpeded, escaping the core where nuclear reactions occur long before photons random walk their way to the surface. Neutrino detectors on Earth sometimes see solar flares in neutrino emissions before optical telescopes see them in light. Could 3I Atlas be detecting neutrino flux changes? Dr. Arthur MacDonald, Nobel laureate for neutrino research, reviewed the hypothesis skeptically. Neutrino detection requires massive instruments, thousands of tons of water or liquid scintillator, to catch even a tiny fraction of passing neutrinos. An object a few kilometers across with no visible detection apparatus shouldn't be sensitive to neutrino flux variations. The cross-section is too small. Yet he acknowledged that exotic materials or unknown mechanisms might exist that could amplify neutrino interaction. Not known physics, but not impossible physics. Third, the correlation isn't causal, but systemic.
Perhaps both the solar event and 3I Atlas's magnetic shift respond to a common underlying driver, some fluctuation in the sun's deep magnetic field that manifests at the surface 8 to 11 minutes after affecting interplanetary space. This would preserve causality, no faster-than-light signaling, just a shared response to a common cause.
The problem: no known mechanism for how deep solar magnetism could influence distant objects directly while taking 8-11 minutes to produce visible surface effects. Solar physicists understand the sun's internal structure reasonably well. Magnetic fields generated by the dynamo in the convection zone take hours to days to percolate to the surface, not minutes. Unless something about 3I Atlas made it sensitive to magnetic field patterns that Earth-based instruments couldn't detect, subtle precursors that propagated outward ahead of the main disturbance. The Maya achieved astronomical predictions that modern science struggles to explain through casual observation alone.
They calculated Venus cycles accurate to within 2 hours over 500 years. They predicted solar eclipses decades in advance. Some researchers propose they had access to records spanning centuries, accumulating data that revealed long-term patterns. Others suggest intuitive understanding of celestial rhythms through deep observation. But a third possibility exists: that the Maya detected signals we've learned to ignore, not through instruments, but through sensitivity to environmental rhythms, magnetic fluctuations, atmospheric changes, subtle correlations that informed prediction. Indigenous knowledge systems worldwide speak of people attuned to nature's rhythms in ways modern science has difficulty quantifying. Not supernatural, but operating through pattern recognition and sensitivity that technology-dependent cultures have lost. Could 3I Atlas possess similar attunement? Not consciousness, but physical sensitivity to environmental patterns that allow anticipatory response. Dr. Merav Ofer at Boston University studies the heliosphere, the bubble of influence the sun creates in interstellar space. Her models show the solar magnetic field extends far beyond the visible corona, creating complex structures that ripple and shift.
Perhaps these structures carry information patterns in magnetic field topology that propagate as waves through plasma, not electromagnetic waves moving at light speed, but magnetohydrodynamic waves that can move faster through certain media. If Tesla were exquisitely sensitive to these waves, it might detect changes in the magnetic environment before those changes manifested as optical solar events. This wouldn't violate relativity. The waves are still constrained by physical propagation, but their information content could arrive ahead of the photons we use to define event timing. The synchronization extended beyond solar events. When the object's magnetic pulse cycle was mapped against Earth's magnetosphere fluctuations, researchers found weak but measurable correlation. During geomagnetic storms triggered by solar wind variations, 3I Atlas's pulse period would lengthen slightly, sometimes by as much as 10 seconds.
Earth and 3I Atlas were separated by hundreds of millions of kilometers. No direct physical connection existed, yet both responded to solar wind conditions with coordinated adjustments. It was as if they were dancers responding to the same music, keeping rhythm with each other, not through communication, but through shared sensitivity to environmental beat. Pythagoras taught that celestial bodies produce harmonious tones through their movement, the music of the spheres. Each planet, he believed, emitted a sound based on its orbital speed and distance from the central fire. These sounds were inaudible to human ears, which had grown too accustomed to them from birth, but they existed nonetheless, creating cosmic harmony that governed the structure of reality. Modern astrophysics rejects literal celestial music. Space is vacuum. Sound requires a medium.
But the metaphor captures something true. Celestial bodies do oscillate, vibrate, resonate at specific frequencies determined by their physical properties. The sun oscillates. Earth's magnetic field pulsates. Even galaxies exhibit cyclic behavior over millions of years. These are not random fluctuations, but determined by structure, composition, and energy input. They create patterns, rhythms that repeat and interact. Perhaps 3i Atlas had found its place in that rhythm, not randomly drifting, but moving in sync with solar and planetary cycles, not through intention, but through physical resonance like a tuning fork that vibrates when its matched frequency is struck nearby. The synchronization raised uncomfortable questions about observation and isolation. Science assumes objects can be studied independently, their properties measured without reference to surroundings beyond immediate gravitational and electromagnetic influences.
But quantum mechanics already challenges that assumption. Entangled particles exhibit correlations regardless of separation. The famous spooky action at a distance that troubled Einstein suggests the universe is more interconnected than classical physics allows. 3i Atlas wasn't quantum entangled with the Sun or Earth, but it demonstrated classical correlation coordinated behavior without apparent causal mechanism. In ecology, this is called indirect mutualism. Two species that don't interact directly nonetheless benefit from each other's presence through their shared impact on the environment. In systems theory, it's called emergence. Complex patterns arising from simple interactions among components creating global coherence without central control.
Perhaps the solar system itself was a system not just a collection of objects, but an integrated whole, where components respond to each other's states through shared sensitivities, creating synchronized behavior that looks like coordination, but emerges from distributed responsiveness. If so, 3i Atlas wasn't an alien visitor. It was a participant entrained into solar system rhythms, through its passage becoming part of the system's dance. The Hermetic principle, as above so below, suggests that patterns at one scale mirror patterns at another. The macrocosm reflects the microcosm. What happens in the heavens mirrors what happens on Earth. This wasn't mysticism, but observation that natural law operates consistently across scales. Gravity governs falling apples and orbiting planets. Electromagnetism shapes atomic bonds and galactic structures. Perhaps synchronization, too, operates at all scales. From the phase locking of coupled pendulums, to the entrainment of circadian rhythms, to the coordination of objects across solar system distances, the universe might favor coherence over chaos, pulling disparate elements into shared rhythms. 3i Atlas suggested that even an object from interstellar space forged under alien suns could find its place in our system's rhythm. Not immediately, but through the transformative passage through perihelion, a rite of initiation that attuned it to local conditions. As winter deepened and the object continued outward, the synchronization persisted, weaker, harder to measure, but present, a faint correlation between its pulses and solar conditions. It was dancing to music we could barely hear, responding to rhythms we couldn't detect, participating in a cosmic symphony that existed not as sound, but as coordinated vibration. And in that participation, it demonstrated something profound, that the universe doesn't consist of isolated objects, but of participants in shared patterns, nodes in networks of influence that extend further than we imagined. The synchronized universe, where nothing exists alone. Radio silence in deep space is the norm. The universe doesn't broadcast. Most cosmic radio emission is thermal noise, the faint static of matter at any temperature above absolute zero. Occasionally, pulsars click with mechanical precision. Quasars roar with electromagnetic fury. But most objects drift silent. On November 14th, 2025, that silence broke. The Meerkat radio telescope array in South Africa, comprising 64 dishes spread across the Karoo Desert, detected a narrow band signal at 1.665 and 1.667 gigahertz. The frequencies are significant. They correspond to the emission and absorption lines of hydroxyl OH radicals, molecular fragments that form when water molecules break apart. The signal was weak, barely above background noise, but it was real, confirmed across multiple antennae, and it was coming from the direction of 3i Atlas.
Dr. Fernando Camilo, chief scientist at the South African Radio Astronomy Observatory, spent 3 days verifying the detection. Equipment checks, calibration runs, cross-referencing with other observatories. The signal persisted, faint, intermittent, but undeniably originating from the object's position in space. What made it remarkable wasn't just the detection. Hydroxyl emissions occur around many comets and asteroids. What stood out was the timing. The radio pulses occurred in bursts lasting exactly 0.88 seconds, repeating every 3.9 minutes. Synchronized perfectly with the magnetic cycle. Radio waves from natural sources are typically either continuous or random in timing. Pulsars emit with precise periods, but their pulses are microseconds to seconds long, not synchronized to other observable cycles.
3I Atlas was emitting radio bursts tied to its magnetic rhythm with precision that suggested coupling, one process driving another. Hydroxyl radicals form when ultraviolet light splits water molecules. In cometary comas, this happens continuously as solar radiation bombards, the ice creating a steady glow of OH emission. But 3I Atlas wasn't near the sun anymore. It was weeks past perihelion, far into the cold outer system where solar UV intensity had dropped significantly. Yet the OH signal persisted, pulsing rhythmically. This implied internal UV generation or particle bombardment from within, energetic processes still active inside the object, releasing stored energy in bursts that coincided with magnetic pulses. Dr. Imke de Potter at UC Berkeley noted that the phenomenon resembled magnetospheric emissions from Jupiter. When charged particles trapped in Jupiter's magnetic field spiral along field lines, they emit radio bursts at specific frequencies.
But Jupiter is massive with a powerful magnetosphere sustained by rapid rotation and metallic hydrogen currents. 3I Atlas was tiny. By comparison, no internal dynamo, no obvious power source, yet it was mimicking behavior seen only in planetary systems, magnetic confinement and controlled particle release. In August 1977, Ohio State University's Big Ear radio telescope detected a signal so strong, so unusual, that astronomer Jerry Amon wrote, "Wow," in the margin of the printout. The WOW signal lasted 72 seconds, peaked at 1.42 gigahertz near the hydrogen line, and never repeated despite decades of subsequent observation. Its origin remains unknown. Some believe it was an artificial transmission from an extraterrestrial civilization. Others argue it was a natural but rare phenomenon, perhaps a pulsar or flaring star momentarily bright at just the right frequency. The signal came from the direction of Sagittarius, near the galactic center. So did 3I Atlas, Dr.
Avi Loeb noted the coincidence in a paper published in late November. The trajectory of 3I Atlas, when traced backward through interstellar space, passed within 9 degrees of the WOW signal's origin point. 9 degrees is not close, by astronomical standards, hundreds of light years of separation. But it's closer than random chance would predict, given the vast size of the galaxy. Correlation isn't causation. The timing doesn't even match. The WOW signal occurred 48 years before 3I Atlas arrived. If they're connected, it would require coincidences of trajectory and timing that strain probability. But the human mind seeks patterns. And when two mysteries originate from the same region of sky, speculation follows. Could the WOW signal have been a transmission related to objects like 3I Atlas, not communication, aimed at Earth, but incidental emission from spacecraft probes or artifacts passing through our radio sphere? The hypothesis is wild. It requires assumptions about extraterrestrial technology, interstellar travel, and motivations we can't justify. Yet the radio pulses from 3I Atlas suggested this wasn't just a rock. Something inside was active, energetic, generating emissions tied to magnetic cycles with precision that resembled engineered systems. Not proof, but a whisper, a hint that the universe might be more complicated than our instruments can fully decipher.
Aboriginal Australian cultures speak of the dream time, the period when ancestral beings walked the earth, creating features of the landscape through their actions and song. The dreaming is not just history, but a continuous present accessible through ritual and connection to land. In some traditions, the ancestors left signs, rock formations, water sources, celestial patterns that encode knowledge. The landscape itself becomes a mnemonic device, holding information across generations. What if celestial objects too carry encoded information? Not in the sense of deliberate messages, but as artifacts of their formation and history patterns in their composition behavior emissions that tell stories to those who know how to read them. 3i Atlas was emitting a pattern, a simple one, a pulse every 3.9 minutes synchronized across magnetic, thermal, and radio domains. Whether that pattern encoded information or was simply the object's natural frequency is unknowable. But patterns are information. Rhythm is structure, and structure carries meaning even if we can't decipher it. The SETI Institute, long dedicated to searching for signals from extraterrestrial civilizations, added 3i Atlas to their observation schedule, not because they believed it was artificial, but because its radio signature was anomalous enough to warrant monitoring. Dr. Seth Shostak, senior astronomer at SETI, was characteristically cautious. Unusual doesn't mean artificial. The universe is full of phenomena we don't understand, but when something emits regular radio pulses, we pay attention. That's our job. The Institute's Allen Telescope Array monitored the object through December. No structured signal emerged, no modulation that suggested data transmission. Just the steady pulse, unchanging, inelegant, more like a lighthouse than a conversation. But lighthouses are built. They serve a purpose, warning, guiding, marking location. A natural lighthouse would be, what, a pulsar perhaps. But pulsars are neutron stars spinning, remnants of supernovae, their pulses generated by rotation and magnetic axis misalignment. 3i Atlas was none of that. It was small, solid, and yet pulsing with regularity that evoked design. By January 2026, the signal had weakened below detection threshold. Distance and declining activity combined to silence the radio whisper. The last clear detection came on January 11th from the Parkes Observatory in Australia, a faint flicker at 1.667 gigahertz, then nothing. The silence that followed felt expectant. Not the absence of signal, but the space after speech where response might come. None came. The Voyager spacecraft, launched in 1977, carry Golden Records audio and images encoded on metal discs, information about Earth and humanity, sent into the void in case any intelligence ever encounters them. Those records pulse with data structure intention. If alien civilizations found them millions of years from now, they would know immediately this is not natural. This carries meaning. 3i Atlas's pulses carried no such clarity. No encoded images, no mathematics, no prime numbers signaling intelligence. Just a rhythm, a heartbeat, a cosmic metronome marking time in the dark. Whether that rhythm meant something or was simply the object's way of existing remains unknown. But for a few months, humanity listened as this visitor from interstellar space broadcast its presence in the only language it possessed, the electromagnetic whisper of its own sustained vibration. And then the whisper faded, swallowed by distance and the cacophony of cosmic noise. But it had been heard, recorded, analyzed. A voice from the deep saying nothing and everything at once. A reminder that the universe contains sounds we're only beginning to learn how to hear. In science, uncertainty is not weakness, it's honesty. And by December 2025, the scientific community was fractured in its certainty about what 3i Atlas actually was. Three camps emerged, each with compelling arguments, each unable to fully explain all observations. Theory 1, the exotic natural object. 60% consensus. The conservative majority held that 3i Atlas, while extraordinary, remained fundamentally natural, a product of astrophysical processes that occurred under conditions rare but not impossible in the universe. Dr. Michelle Bannister at the University of Canterbury summarized this view: interstellar space is vast and ancient. Matter there has been subjected to conditions we can barely simulate: supernova remnants, neutron star collisions, dense molecular clouds. We shouldn't be surprised when fragments from those environments behave strangely by our standards. The formation hypothesis goes like this: billions of years ago, in a stellar system far from ours, a planet formed around a metal-rich star. The planet's core accumulated heavy elements: iron, nickel, chromium, molybdenum, in concentrations far exceeding Earth's. Then catastrophe. Perhaps the star went supernova. Perhaps a planetary collision shattered the world. The core fragmented and pieces were ejected into interstellar space. Over geological time spans billions of years, these fragments drifted through the galaxy, exposed to cosmic rays, interstellar radiation, and magnetic fields. Materials that would be unstable on Earth might persist in the cold vacuum of space. Molecular structures impossible under terrestrial conditions could form slowly through low-temperature quantum tunneling processes. When this fragment encountered the Sun, the intense heat triggered transformations. Materials that had been metastable, held in unstable configurations by the cold, reorganized rapidly. The absorbed plasma filled microscopic pores, adding mass. Magnetic domains aligned under solar field influence, creating the observed pulsations. Every anomaly in this view stems from exotic but natural material properties, combined with the object's unique history. The magnetic rhythm, resonance from internal structure, layered materials expanding and contracting thermally, generating current loops that pulse as different layers cool at different rates. The radar silence. Microstructures that evolved in interstellar space happen to absorb electromagnetic radiation efficiently, like naturally formed metamaterials. The compositional stability. The materials reached thermodynamic equilibrium during perihelion, finding the configuration of lowest energy. The theory has strengths. It requires no new physics. It invokes only known processes operating under unfamiliar conditions. It's parsimonious. Occam's razor favors the simplest explanation that fits the data, but it struggles with the coordination. Why does everything magnetism, thermal emission, radio pulses synchronize so perfectly? Natural resonance can produce rhythms, but multiple independent systems falling into exact phase seems improbable without coupling mechanisms. Theory 2. Adaptive natural phenomenon. 25% consensus. A smaller group proposed something more radical: that 3I Atlas represented a class of self-organizing systems that occur naturally when matter reaches sufficient complexity under extreme conditions. Dr. Stuart Kauffman, a theoretical biologist, spent decades studying how complexity emerges from simple rules. His work on autocatalytic set systems, where components catalyze each other's formation, showed that self-organization isn't exclusive to life. Chemical reactions can create feedback loops. Under the right conditions, these loops sustain themselves, creating order from chaos without requiring genetic code or cellular structure. Perhaps matter in extreme environments, strong magnetic fields, high radiation temperature cycling can organize into structures that regulate their own states. Not alive, but not simply passive either. The analogy is with Bénard cells, patterns that form in heated fluids. Heat a pan of oil and hexagonal convection cells spontaneously appear. The cells aren't designed. They emerge from the physics of heat flow in viscous fluids. Could 3I Atlas represent matter self-organizing on a larger scale? The perihelion passage provided energy input. The object's composition provided the substrate. Self-organized patterns, emerged magnetic rhythms, thermal regulation, structural ordering, all arising from the system seeking stable attractors in a complex energy landscape. This theory explains the coordination naturally. If all observed phenomena stem from a single self-organizing process, they'll automatically be synchronized because they're manifestations of the same underlying dynamics. Dr. Ilya Prigogine won the Nobel Prize for his work on dissipative structures systems, far from thermodynamic equilibrium, that maintain organization by dissipating energy. Hurricanes are dissipative structures, so are living cells. Perhaps 3I Atlas became a dissipative structure during perihelion organizing itself to efficiently absorb and release solar energy, and that organization persisted after the energy input ceased. The weakness dissipative structures require continuous energy input. They collapse when the flow stops. Yet 3I Atlas maintained organization for weeks after leaving the sun's vicinity, unless it stored enough energy internally to sustain the structure temporarily, like a spinning top that continues balanced motion after the initial twist, gradually slowing but maintaining form. The theory is elegant but speculative. It pushes natural explanation to its limit, proposing processes that haven't been observed elsewhere but aren't forbidden by physics. Theory 3. Engineered or ancient construct. 15% consensus. A small but vocal minority suggested that 3I Atlas might not be natural at all, that its behavior indicated engineering, either by biological intelligence or through processes so advanced they appear indistinguishable from natural law. Dr. Avi Loeb led this camp. His argument was straightforward. If you encountered an artifact billions of years old, shaped by technologies you didn't understand, would you recognize it as artificial? Ancient texts describe the Vimanas flying machines mentioned in Sanskrit epics like the Mahabharata and Ramayana. They're described in mechanical detail, powered by mercury vortices capable of flight through air and space protected by energy shields. Scholars dismiss these as mythology, imagination, literary metaphor. But what if they were attempts to describe real phenomena in the only language available, not alien spacecraft necessarily, but natural objects whose behavior seemed so purposeful that ancient witnesses interpreted them as machines? The Dogon people of Mali possess astronomical knowledge that puzzles ethnographers. They describe Sirius as a triple star system, Sirius A visible to the naked eye plus Sirius B, a white dwarf companion, invisible without telescopes, discovered by Western science only in 1862. The Dogon claim this knowledge came from the sky beings called Nomo, who visited long ago. Either the Dogon independently discovered Sirius B through unknown means they were taught by Western visitors and incorporated it into their mythology, or they had access to information from sources we don't understand. Applying that lens to 3I Atlas, what if it's a probe, not a crude vessel but an automated explorer launched millennia ago by a civilization that understood how to create machines from materials indistinguishable from natural matter? The concept is called the Bracewell probe, after Ronald Bracewell, who proposed that extraterrestrial intelligences might explore the galaxy using self-replicating, autonomous spacecraft rather than sending signals. These probes would move slowly between stars, gathering data, perhaps reporting back to their creators. They'd be designed to survive interstellar transit, billions of years of radiation dust impacts, temperature extremes. What would such a probe look like? Probably not chrome and wires. After billions of years, wear and impact would leave it resembling a natural object. But its internal structure might persist. Scaffolding that guides behavior stores, energy responds to environments. The theory fits uncomfortably well. The magnetic regulation, power management, the thermal control, maintaining optimal operating temperature, the plasma absorption, refueling by harvesting stellar matter, the radio pulses, not communication but telemetry status signals, broadcast automatically perhaps toward a destination long abandoned or a civilization long extinct. The geometric surface patterns, sensor arrays, or functional structures eroded but still operational. It's speculation clearly, without direct examination, without landing on the object and analyzing its interior. The probe hypothesis remains unprovable, but it's also unfalsifiable.
Any evidence consistent with natural origins is equally consistent with sufficiently advanced engineering mimicking natural processes. The Hermetic tradition taught that nature and artifice aren't opposites, but points on a continuum. Alchemy sought to perfect nature's work through human intervention, not to oppose nature, but to collaborate with it.
Perhaps intelligence at a certain level doesn't build against nature, but with it creating technologies that harness natural law so efficiently they become indistinguishable from natural phenomena. Arthur C. Clarke famously stated, "Any sufficiently advanced technology is indistinguishable from magic." By extension, any sufficiently advanced technology might be indistinguishable from nature itself. The uncomfortable middle ground. Most researchers found themselves unable to commit fully to any theory. The data supported aspects of all three while perfectly fitting none. What emerged was a peculiar consensus that 3i Atlas occupied a category we didn't have language for, not clearly natural in the way asteroids and comets are natural, not obviously artificial in the way spacecraft and satellites are artificial. Something else. Something that blurred the distinction. Dr. Sarah Seeger coined a term during a December conference, ambiguously organized matter.
Matter that exhibits organization without clear, natural, or artificial origin. The phrase spread quickly, capturing the frustration and fascination of the scientific community. Because whether 3i Atlas was a strange rock, a self-organized system, or an ancient machine, it demonstrated something profound, that the universe contains entities that don't fit our categories, things that exist in the spaces between our definitions. And perhaps that's the real discovery, not what 3i Atlas is, but that our taxonomy of existence is incomplete. The universe is not neatly divided into natural and artificial living and non-living, random and designed. Those are human categories, useful but limited. Reality is messier, more complex, with phenomena that occupy multiple categories simultaneously or none at all. 3i Atlas became a symbol of that complexity, a reminder that knowledge begins with observation but sometimes ends with mystery.
And that in science the highest wisdom might be knowing what we don't know. On a clear night far from city lights, you can see about 2,500 stars with the naked eye. Ancient peoples saw the same stars and asked the same question. Are we alone? For thousands of years, the answer was unknowable. Now, after 3i Atlas, the question has changed. Not, are we alone, but would we recognize others if they're already here? The observation of 3i Atlas forces a profound shift in perspective. If interstellar objects can exhibit organized, apparently purposeful behavior, then the cosmos might be far more complex than our simple binary of living versus non-living allows. Dr. Caleb Scharf at Columbia University studies astrobiology and the search for life beyond Earth. His work focuses on expanding our definition of what life might be. Silicon-based, energy-based, even information-based patterns that persist and propagate without requiring physical embodiment. 3i Atlas doesn't meet any traditional definition of life. It doesn't reproduce, metabolize in conventional ways, or respond to stimuli through biochemistry. But it does maintain organization against entropy. It does store and release energy. It does respond to environmental changes with behavior that appears adaptive. If those are insufficient criteria for life, what are sufficient? The question matters because it determines how we interpret signals from the cosmos. SETI searches for radio transmissions, assuming intelligence communicates through technology. But what if intelligence at certain scales or ages manifests as stable patterns in matter itself? What if the galaxy is full of objects like 3i Atlas engineered or evolved structures that interact with stars, absorb energy, maintain organization across billions of years, and we've been calling them asteroids? The Fermi paradox asks if intelligent life is common. Where is everybody? The galaxy is billions of years old.
Even at sublight speeds, civilizations should have colonized it thoroughly by now, yet we see no evidence. Perhaps we see plenty of evidence, but don't recognize it. Perhaps colonization doesn't mean planets covered in cities, but interstellar space, filled with objects that harvest starlight, navigate gravitational fields, persist across ages, objects that look to our instruments like rocks. 3i Atlas challenges our assumptions about scale and time. Human civilization is 10,000 years old. We've had radio for 1 century. We've sent probes to the outer solar system but haven't reached interstellar space. Now imagine technology 10 million years more advanced. What would it look like? Would it still be chrome and circuitry, or would it have converged with natural principles becoming indistinguishable from physics itself? The ancient concept of panpsychism holds that consciousness is fundamental to the universe, not emergent from complexity. Philosophers from Thales to Spinoza to Whitehead propose that mind is woven into the fabric of reality at all scales. Modern science dismissed this as mysticism. Consciousness, we believed, arose from brain complexity neurons firing in networks producing the emergent property of awareness. But quantum mechanics introduced observer effects. Information theory suggested that reality might be fundamentally informational. Integrated information theory proposed that consciousness exists wherever information is integrated, meaning even simple systems possess rudimentary awareness. If consciousness is the organization of information in ways that allow self-reference, then systems like 3i Atlas maintaining internal states, responding to environments, preserving identity across time, might possess something we'd have to call proto-consciousness. Not human awareness, not self-reflection, but a kind of existence that's more than mere matter, less than life, and possibly the substrate from which both emerge. This isn't mysticism, it's philosophy catching up with physics. The universe doesn't divide neatly into thinking and non-thinking. There's a spectrum, and we're only now developing tools sensitive enough to explore its subtle gradations. The Maya calendar system tracked cycles within cycles, days, months, years, backtunes culminating in the great cycle of 525 years. Each cycle's end and beginning was marked by cosmic signs believed to herald transformation. The Maya didn't see time as linear but as recursive folding, back on itself, creating resonances between past and future. Events don't simply happen. They echo across temporal scales. Perhaps 3i Atlas is an echo, evidence of processes, entities, or intelligences that existed long ago, still resonating through space in the form of objects that carry memory in their structure. We're not encountering aliens. We're encountering their artifacts, their remnants, perhaps even their transformed states after billions of years of evolution or entropy. And if we can't distinguish those from natural objects, perhaps the distinction was always false. Perhaps intelligence and nature were never separate categories. The practical implications are staggering. If objects like 3i Atlas exist throughout the galaxy, they represent resources, dangers, and opportunities we haven't imagined. Resources, materials, and technologies beyond our current capabilities. If even natural objects from other stellar systems possess exotic properties, mining and studying them could leapfrog our materials science centuries forward. Dangers: if we can't distinguish advanced technology from natural phenomena, we can't assess threats. Planetary defense programs focus on collision risk. But what if some incoming objects aren't just rocks? What if they're actively stabilizing their trajectories, adjusting their paths in ways we don't detect? Opportunities contact might not come through radio signals, but through encounters with objects that carry information in their structure-behavior emissions. Learning to read those signs could be humanity's next great challenge. The ancient Library of Alexandria held hundreds of thousands of scrolls, humanity's accumulated knowledge from across the known world. Its destruction was one of history's great losses. Imagine if libraries could be written in stone in patterns that persist for millions of years.
Imagine if information could be encoded in crystal lattices, magnetic domains, compositional arrangements that survive interstellar travel. What if objects like 3i Atlas are books? Not carrying language, but carrying principles, demonstrations of physics, chemistry, engineering that reveal themselves to civilizations patient and skilled enough to read them. We think of SETI as listening for messages. Perhaps SETI should also include material analysis studying interstellar objects, not just as geology, but as potential information carriers. The shift in perspective that 3i Atlas demands is profound, from seeing the universe as dead matter with rare pockets of life to seeing it as a continuum where organization, complexity, and even intelligence exist in forms we're only beginning to recognize. This doesn't diminish humanity. It expands our context. We're not special because we're the only intelligence, but because we're capable of recognizing others, however different they may be. In the Vedic tradition, the concept of Nada Brahma, sound is God, suggests that reality is fundamentally vibrational. The universe isn't made of things, but of processes, rhythms, patterns that create the appearance of solid matter. Modern physics echoes this. Quantum field theory describes particles as excitations in fields. String theory proposes that everything is vibration at Planck scale. The universe is less substance than song. If reality is pattern and rhythm, then objects that maintain patterns like 3i Atlas with its magnetic pulse, its thermal cycles, its geometric surface are participating in reality's fundamental nature more directly than we thought. They're not alien, they're native speakers of the universe's language. And we, learning slowly to understand that language, are beginning to hear what they've been saying all along. That existence is not a binary. That organization is not exclusive to life. That intelligence might be woven through the cosmos in ways we're only beginning to perceive. 3i Atlas changed nothing about the universe, but it changed everything about how we see it. And that perhaps is the most significant discovery of all. December 19, 2025, the date circled in red on calendars across a dozen observatories. On that day, 3i Atlas would reach its closest approach to Earth since discovery, approximately 1.8 astronomical units, about 170 million miles. Still distant by terrestrial standards, but near enough for optimal observation, with instruments that had been tracking its journey for 5 months. The anticipation was electric. Every major telescope had secured observation time. The James Webb Space Telescope reallocated precious mirror time. Hubble was retasked. Ground-based infrared arrays from Hawaii to Chile prepared coordinated campaigns. This would be humanity's best and possibly last chance to study the object before it faded beyond the reach of even our most sensitive instruments. The goals were clear: complete compositional analysis. Webb's near-infrared spectrograph could detect molecular fingerprints invisible to other instruments. If 3i Atlas contained organic compounds, exotic ices, or mineral combinations that revealed its origin, Webb would find them. Internal structure mapping. Radar facilities at Arecibo's successor in Goldstone would attempt deep penetration scans looking for cavities. Layers, anything that might explain the density paradox and radar silence. Magnetic field topology. The solar orbiter, though no longer close to the object, would coordinate with Earth-based magnetometers to triangulate the field's three-dimensional structure, searching for patterns that might reveal its source. Thermal and radio monitoring. Around-the-clock observation to capture any changes in the thermal cycle or radio emissions. If patterns shifted as the object moved farther from the sun, the timing would be crucial data. And underlying all of it, the unspoken hope that 3i Atlas might do something. Change. React. Respond. Not because anyone truly believed it was communicating, but because the object had surprised them at every turn. Why should the close approach be different? The Maya believed in cosmic ages, periods of creation and destruction marked by celestial events. Each age ended with a cataclysm, flood, fire, wind. But each also began with a sign, a marker in the heavens that announced transformation. In their cosmology, observing the signs was sacred duty. The sky was a book, and those who could read it gained wisdom that protected their people. Modern astronomers don't speak of sacred duty, but the sentiment is similar. To observe is to understand. To understand is to prepare. If 3I Atlas represented a new class of object common in the galaxy but previously unrecognized, then studying it thoroughly now would set the template for understanding others that follow, and others would follow. Statistically, interstellar objects pass through the inner solar system more frequently than previously thought. Oumuamua, 2E Borisov, 3E Atlas 3 in 8 years. The detection rate is limited only by our search capabilities. As surveys improve, more will be found. Some might be ordinary comets or asteroids ejected from their home systems. Others might be like 3I Atlas strange, organized defying easy classification. By late November, mission planners at NASA and ESA had begun discussing something unprecedented: interception. If 3I Atlas represented a genuine mystery, possibly artificial, possibly containing materials or mechanisms unknown to science, shouldn't humanity attempt to study it up close? Not just observe from afar, but send a probe to intercept, land, analyze. The idea wasn't new. After Oumuamua's discovery, proposals emerged to send rapid response missions to intercept interstellar objects. The technology exists. Nuclear thermal propulsion or solar sails could reach high velocities quickly. A small probe launched with months of warning could potentially catch an object before it escapes the inner solar system. But Oumuamua was already receding when proposals were drafted. The window had closed. With 3I Atlas, there might still be time. Its trajectory, now well characterized, showed it would pass Jupiter's orbit in March 2026. After that, it would fade beyond practical reach for decades. A mission launch before year's end might intercept near Jupiter, matching velocity, deploying instruments, possibly even landing a small payload. Dr. Elizabeth Howell at the Canadian Space Agency drafted a white paper proposing an international collaboration, fast-track mission development, shared costs between space agencies, a probe no larger than a refrigerator stripped to essentials: cameras, spectrometers, magnetometer drill. The goal, not to capture 3I Atlas, but to touch it, to understand. The proposal circulated quietly through December. Reactions were mixed. Some called it scientifically imperative. Others dismissed it as hasty, underfunded, impossible to execute on such short timelines. Politically, the idea faced hurdles. Space missions require years of planning, approvals, funding battles. Asking governments to approve a billion-dollar mission on months' notice was unrealistic. But the discussion alone marked a shift. For the first time, humanity was seriously considering direct interaction with an interstellar object. The possibility hung in the air that we might not just observe visitors from beyond, but reach out, making contact in the most literal sense. Whether that happens for 3I Atlas or a future object remains to be seen. But the precedent is set. The conversation has begun. Göbekli Tepe in Turkey dates to 9600 BCE, older than Stonehenge, by 6 millennia older than writing, older than agriculture. Its massive stone pillars, arranged in circles, align with celestial events. It was an observatory, a temple, a monument to humanity's need to understand the sky. The builders had no telescopes, no spectrometers, just their eyes, their patience, and their recognition that the heavens mattered. They carved animals into the stones: snakes, scorpions, birds. Scholars debate their meaning. Some suggest they're constellations, others think they're symbolic. A few propose they're records of impact events, cometary disasters encoded in stone as warning. We'll likely never know for certain, but the intent is clear. The ancients watched the sky because what happened there affected them. They built monuments to preserve that knowledge across generations. We're doing the same, not with stone circles, but with telescopes, data archives, mission proposals, building infrastructure to observe, record, and understand. The difference is scale and tools. The impulse remains identical.
As December 19th approached, the observatories prepared. Schedules were finalized. Instruments were calibrated. Scientists cleared their calendars knowing that the data from this brief window might fuel research for years. And across the world, in smaller numbers, amateur astronomers trained backyard telescopes toward the coordinates. 3-Eye Atlas was too faint for most to see directly, but the act of pointing mattered. The act of looking, because observation is humanity's oldest ritual. Long before we understood what stars were, we looked at them. Long before we could explain eclipses or comets, we watched them. We're watchers, witnesses, the species that asks, "What is that?" and refuses to accept, "I don't know," as final answer. 3-Psi Atlas would pass, the observations would be made, data would accumulate, and slowly over months and years, understanding would deepen, but complete understanding that might remain forever out of reach.
Some mysteries don't yield to observation alone. They require context. We don't possess frameworks, we haven't developed questions we haven't learned to ask. The Nazca lines in Peru stretch across the desert, enormous geoglyphs visible only from the air. Their purpose remains debated. Ceremonial pathways, astronomical calendars, messages to the gods. Perhaps they served all these functions. Perhaps they were simply art, the expression of a culture's need to create something larger than themselves, visible to the cosmos even if no one was looking. 3-Eye Atlas will leave its own geoglyphs in our data, patterns in spectra, curves in brightness graphs, radio whispers preserved in archives. Long after it fades from view, those patterns will remain studied by future scientists with better theories, more advanced models, perspectives we can't yet imagine. And maybe, just maybe, someone will look at those patterns and see what we missed. The hidden order, the subtle sign. The message encoded not in language, but in behavior. Not, "Hello, but look closer." Not, "We are here, but you are learning." For now, the telescopes turn. The instruments listen. Humanity watches as another wanderer passes through our small corner of space, carrying with it questions we're only beginning to ask, and answers we may never fully hear. The data arrives in silence. Megabytes per second. Through fiber optic cables, satellite uplinks radio dishes pointed at the dark. No fanfare, no announcement. Just photons converted to electrons, electrons to numbers, numbers to images and graphs that appear on screens in mission control rooms around the world. This is how discoveries happen now. Not with sudden revelations, but with the gradual accumulation of observations, the slow construction of understanding from fragments of light. 3-Eye Atlas has given us those fragments: spectral lines, magnetic measurements, thermal curves, radio pulses. Each one a word in a language we're still learning to read. Let's be clear about what we know for certain. It came from interstellar space. Its hyperbolic trajectory, traced backward, leads beyond the solar system toward the constellation Sagittarius. It formed under another star or in the depths between stars and traveled for eons before passing through our region of the galaxy. It survived extreme solar proximity, where comets fragment and asteroids shed mass. 3-Eye Atlas emerged intact, apparently strengthened by the passage. Its density increased its surface, transformed its internal structure, reorganized. It exhibits rhythmic behavior, magnetic pulses every 3.9 minutes, thermal oscillations in synchronized cycles, radio emissions tied to the magnetic rhythm. The regularity suggests order, whether through natural resonance or active regulation. It absorbs more than it reflects. From radar to visible light, 3-Eye Atlas takes in radiation more efficiently than natural objects typically do. Its internal structure remains opaque to remote sensing, hidden behind surfaces and mechanisms that prevent easy observation. It maintains organization against entropy. Weeks after leaving the sun's vicinity, it continues to radiate stored energy in controlled fashion. Its temperature regulated its magnetic field, persistent. Natural cooling should be faster, more chaotic. This is neither. These are not interpretations, they're observations. Data confirmed across multiple instruments, multiple observatories, multiple independent analyses.
What remains unknown? What may always remain unknown is the question beneath the observations. What is this? Is it a fragment of planetary core ejected billions of years ago, carrying exotic materials that behave in ways we haven't seen because we've never encountered matter forged under such conditions? Is it a self-organizing system where complexity reached a threshold that allowed emergent properties, rhythm, regulation, apparent purpose to arise from physics alone? Or is it something built? An artifact so old that its origins lie beyond our ability to trace its mechanisms? Eroded by time but still functional, its purpose either forgotten or never intended for us to understand? The honest answer is, we cannot know from observation alone. Ancient peoples looked at the sky and saw gods because they lacked telescopes to reveal that planets were worlds, stars were suns. They saw truth through the lens of their knowledge and their interpretations, while incorrect literally often captured something true metaphorically. We look at 3i Atlas through our telescopes, our spectrometers, our models of physics and chemistry. We see an object that defies easy classification, that behaves in ways requiring explanation. But our explanations are also lenses shaped by what we already know. Just as ancient astronomers couldn't conceive of nuclear fusion powering the sun, perhaps we can't conceive of principles operating in 3i Atlas that lie beyond our current understanding. Not magic, not violation of natural law, simply law we haven't discovered yet. The Greek Stoics taught that the universe is rational, that logos reason-order pattern pervades all existence. Things happen for reasons even when those reasons escape our comprehension. Perhaps 3i Atlas operates according to logos we've glimpsed but not grasped. Its behavior follows rules. The challenge is discerning whether those rules are the familiar ones of gravity, magnetism, and thermodynamics, or whether they include principles we've yet to formalize. In December, as the object reached closest approach and telescopes gathered their final detailed observations, something remarkable happened. Nothing, no sudden change, no dramatic event, no revelation that settled debates or confirmed theories. 3i Atlas continued as it had for weeks, dark, pulsing faintly, moving along its calculated trajectory with precision that betrayed no deviation, no surprise. The anticlimax was itself profound, because it demonstrated that this object, whatever its nature, wasn't performing for us. It wasn't reactive. It wasn't aware of our observation. It simply existed doing what it does, indifferent to humanity's gaze. That indifference might be the most important lesson. We've grown accustomed to the universe being, in some sense, about us. The Earth is our home. The solar system is our backyard. Our instruments probe the cosmos, and we interpret what they find through the lens of how it relates to us, our understanding, our categories. But 3i Atlas reminded us that the universe isn't about us. Objects pass through our system on trajectories determined millions of years ago. They carry histories we didn't witness, properties we don't understand, purposes, if any, that have nothing to do with being observed by a curious species on a small blue planet. The Hermetic axiom, "Know thyself," is often interpreted as psychological advice, but in its original context it meant something deeper. To understand oneself is to understand the universe, because the principles that govern human consciousness are the same principles that govern stars, atoms, and everything between. What does 3i Atlas teach us about ourselves? That our categories are provisional. That natural and artificial might not be fundamental categories but cultural constructs useful at certain scales. That complexity and organization emerge wherever conditions allow, and those conditions are more varied than we imagined.
That mystery isn't a problem to be solved, but a condition to be recognized. Some things remain unknown, not because we lack data, but because the frameworks we use to interpret data are incomplete. That patience is as important as technology. The ancients watched the stars for centuries, accumulating knowledge slowly. We want answers immediately, press conferences, headlines, definitive conclusions. But understanding takes time. The observations of 3i Atlas will be analyzed for years. Future scientists will revisit the data with new theories, new tools, new questions, and perhaps they'll see what we missed. Right now, somewhere beyond Mars, 3i Atlas continues outward. Its glow has faded below the threshold of all but the most sensitive infrared telescopes. Its radio pulses, if they continue, are lost in cosmic static. Its magnetic field is too distant to measure. It's disappearing from our ability to observe, returning to the silence between stars where it spent billions of years before we noticed it for a brief instant of cosmic time. But its influence remains. In the data, in the debates, in the shift it created in how we think about what's possible. Every subsequent interstellar object will be compared to 3i Atlas. Every strange behavior will be measured against its precedent. It has become the benchmark, the example that expanded our concept of what passes through the dark. The Voyager spacecraft, launched in 1977, recently entered true interstellar space. They carry messages from humanity's sounds, images, greetings in multiple languages. The golden records mounted on their sides are intended for anyone who might find them eons from now. But they're also messages to ourselves. Statements of who we were when we sent them, what we valued, what we hoped. 3i Atlas carries no message we can read, but perhaps it carries one nonetheless. A message written in behavior, in properties, in the mere fact of its existence. The message might be, the universe is full, not of civilizations necessarily, but of objects, travelers, remnants, structures that persist across time and space, carrying within them signatures of where they've been, what they've encountered, what they've endured. Every star system sheds matter. Every supernova flings debris across light years. Every planetary system in the galaxy has likely exchanged material through gravitational encounters, ejecting asteroids and comets that become interstellar wanderers. The galaxy isn't a collection of isolated systems. It's a network connected by these travelers, mixing matter and perhaps information across distances that light takes millennia to cross. We're part of that network now, not by sending probes, not yet, but by observing, documenting, understanding, by recognizing that what passes through our system carries meaning, even if we can't fully decipher it. In Zen Buddhism, koans are questions without rational answers. What is the sound of one hand clapping, Akri? The point isn't to solve them intellectually, but to break through intellectual limitation, reaching understanding that transcends logic. 3i Atlas is a cosmic koan. What is an object that behaves like a machine but looks like nature? What is organization without obvious origin? What is silence that suggests speech? The answer isn't in more data. It's in accepting that some questions exist at the boundary of our frameworks, pointing toward truths we don't yet have words for. Perhaps that's the final lesson. Not that we need better telescopes, though we do. Not that we need more funding, though that helps. But that we need humility. The humility to say, I don't know, without shame. The humility to hold multiple contradictory explanations simultaneously without forcing premature certainty. The humility to recognize that the universe is under no obligation to make sense to us on our timelines or in our terms. 3i Atlas is already beyond Neptune's orbit on its way to the heliopause and beyond. In a few decades, it will cross the boundary where solar influence ends and interstellar space begins. It will join the vast population of objects drifting through the galaxy, icy comets, rocky asteroids, metallic fragments, and perhaps others we have no names for. Most will never encounter another star. They'll wander the dark for billions of years, cold and silent, until the universe itself changes around them. But some will pass close to other stellar systems, other worlds, other civilizations if such exist, watching with their own instruments, asking their own questions, reaching their own provisional conclusions. And maybe, just maybe, they'll detect the same patterns we found, the same rhythms, the same hints of organization that made us wonder. They won't know that we were here first, that we observed and debated and marveled. The object carries no record of its passage through our system, no mark that we touched it even with our attention. But perhaps that's fitting, because the universe doesn't keep score. It doesn't care who discovers what first. It simply exists, vast and complex and full of phenomena that emerge, persist and fade according to principles that operate whether we understand them or not. We had our moment with 3I Atlas, a brief intersection of trajectories. This object from interstellar space and our species barely emerged from caves, just learning to read the language of light. We did our best. We observed, measured, recorded. We debated and theorized. We experienced wonder and frustration in equal measure. And now, like the object itself, we move on, but changed, carrying with us the memory of something that passed through and left us with more questions than we had before. That's the gift of mystery. Not answers, but the motivation to keep looking, to keep asking, to keep reaching beyond what we know toward what we might someday understand. Somewhere between Mars and Jupiter, growing fainter by the day, 3I Atlas continues its journey. Silent, dark, pulsing faintly, with rhythms we detected but never explained. It carries within it the heat of our sun, a memory of fire sustained against the cold. And perhaps in some way we don't comprehend, it carries our attention too. The fact that for a few months in 2025, humanity looked and saw something extraordinary. Not proof of aliens or gods, not validation of our cleverness or importance. Just evidence that the universe contains more than we suspected. That reality is stranger than we suppose. And that between the categories we've created, living and dead, natural, and made random and ordered, there exists territory we've barely begun to explore. Territory where objects can be all those things and none of them simultaneously. Where silence speaks if we learn to listen. Where the cosmos reveals itself not in dramatic gestures, but in subtle patterns that persist across ages, waiting for eyes patient enough to notice. And when we notice, when we see, without immediately understanding, when we hold the mystery without crushing it through forced explanation, that's when we're truly doing science. Not the science of conclusions, but the science of wonder. Not the science of knowing, but the science of asking. 3I Atlas will fade, but the questions it raised will echo through astronomy for generations. Every interstellar object detected hereafter will be measured against it. Every strange behavior will invoke its precedent. It changed what we believe is possible, and that change once made is irreversible. We live now in a universe where objects like this exist, where interstellar space harbors complexity we're only beginning to recognize, where the line between natural and artificial might be less clear than we thought. That's uncomfortable. Uncertainty always is, but it's also thrilling, because it means the universe still has secrets, still has surprises, still has the capacity to show us something new and leave us for a while at least genuinely unsure of what we've seen. That uncertainty is not weakness. It's the engine of discovery. It's the space where knowledge grows. And as long as we remain capable of standing in that space, holding questions, without forcing answers, observing, without assuming we understand, as long as we retain that capacity, we remain explorers in the truest sense. Not conquerors of mystery, but students of it. Learning slowly what the universe is willing to teach, one strange object at a time.